Ladies and gentlemen, on behalf of the Moon Village Association and the Cyprus Space Exploration Organization, we warmly welcome you to the 5th Global Moon Village Workshop and Symposium, hosted from Nicosia, Cyprus. My name is Christina Shalis, and I will be the Master of Ceremonies for the duration of this event. We have a great lineup for you for the next 3 days. Before we get started, we would like to thank our sponsors, Lockheed Martin, our grand sponsor, and Luxembourg Space Agency, our silver sponsor. Our media sponsor is the Cyprus News Agency. Please don't forget to visit our repository of presentations from the call for papers. Without further ado, please let us proceed to the opening ceremony with welcoming speeches from the President of the Moon Village Association and the President of the Cyprus Space Exploration Organization.
Ladies and gentlemen, dear colleagues and friends from around the world, good morning, good afternoon, and good evening, depending on where you are. With me is the President of the Moon Village Association, Giuseppe Reibaldi. Giuseppe, good afternoon.
Good afternoon, John.
On behalf of the Cyprus Space Exploration Organization, I am delighted to welcome you to the 5th Global Moon Village Workshop and Symposium. From Nicosia, Cyprus, where we host the control room and coordination of this event, we warmly welcome you. Space exploration, and more specifically, lunar exploration, is going through a brand new golden era. We're living through exciting times with breakthrough discoveries and groundbreaking missions. Nations from around the world are planning new missions to the moon. Humanity is returning to the moon, this time not just for a visit, but to stay. In the next few years, we will see moon settlements on the moon. Science fiction will become our scientific reality. With this workshop and symposium, we are bringing you some of the greatest stakeholders from around the world with their news and announcements. We will be discussing highly important matters and looking how to engage young people around the world in the CSEO MVA Innovation Hackathon. I would like to thank everybody involved in making this event a reality. The Moon Village Association in entrusting us in organizing this event. All of CSEO's team here in Cyprus and around the world. And of course, our sponsors. Lockheed Martin, our grand sponsor. The Luxembourg Space Agency, our silver sponsor. And the Cyprus News Agency, our media sponsor. And now, Giuseppe, I give the floor to you for your introduction from the Moon Village Association side.
So thank you, George, and again, good evening, good morning, good afternoon to everyone. So indeed, we are arrived at the 5th Moon Village workshop, and this is an important milestone. So I will first share with you some of the goal of the Moon Village Association, which is namely to act as a platform to bring together stakeholders from all over the world, stakeholders like industry, space agency, government, academia, international organization, and last but not least, the public. Moon Village Association has been created in 2017, and we hosted the first meeting in Strasbourg in 2017. That's the reason why we are at the 5th meeting. So you can find information about the Moon Village Association looking to the website www.moonvillageassociation.org. Let me now briefly tell you what has happened since last year. So this has been a year full of events, and a lot is coming up next year. So I will touch base briefly on some event which has happened in the world and some of the major achievements of the Moon Village Association. As far as the world, everywhere in the major stakeholder, there are lunar missions being prepared, and there is at least 5 missions which are ready to go to the moon next year. I will mention not in order of importance, but just in an order which I recall. So there is the Luna 25 mission, which is going to be launched by Russia. We're going to have the Chandrayaan-3, going to be launched by Indian Space Research Organization. NASA is going to launch the Artemis 1 mission. We are going to have a commercial mission from Japan, from iSpace, and we're going to have 2 commercial missions from United States, one from Astrobotics, the other one from Masten. So I think at the end of the day, you will see a mission going on to the moon many times during next year. As far as MVA is concerned, we hold during the last year 15 online webinars. And you can find many of them, all of them, on our website. We have basically worked in many areas, and what you see behind me is the result of the first in-depth assessment of the moon village located at the South Pole, basically close to the Shackleton craters. This has been the result of the architecture working group. So these are very exciting results being generated, in particular in one area. The other area which Moon Village Association has given an important contribution is lunar governance. We have started in 2020 with the definition of a common level playing fields about lunar activity, which resulted in the best practice. And we gave birth, incubated the Global Expert Group on Sustainable Lunar Activity. This is now a recognized worldwide group of experts, which is going to provide their input to the COPOS. And then we have given also very strong importance to the young generation. We have initiated a project which is called Towards the Moon Village Generation. And all of these will be discussed, particularly on the third day. I'd like to say a few words about the program. This year, we have given much more interactivity related to how the activity are going on, so people can talk to each other and can exchange information. And so in particular, on the third day, as been mentioned by George, we will have hackathon and education, and that is particularly new. So I would like then to end my introduction by thanking, of course, Cyprus Space Exploration Organization, without whom we will not be able to hold this event, particularly thanks to the CSEO team, to the MVA team, which has organized a lot of all the event, including also the breakout session, to particular Glafki, Antonio is our management support for all the great effort. Thank in particular to the sponsor, the grand sponsor, Lockheed Martin, silver sponsor, Luxembourg Space Agency, and the Cyprus News Agency. I would like basically to conclude by inviting you to be part of the Moon Village Association in whatever activity you find suitable, and bring your idea and support. And with that, you can be part of what we are trying to make history in going forwards to the moon. And with that, I give back the floor to George for the opening of the workshop. George.
Thank you, Giuseppe. Thank you, everybody, for watching us, and welcome and enjoy the proceedings. Let's start the symposium.
Have a good workshop to everyone.
With these welcoming speeches, we are kicking off the 5th Global Moon Village Workshop and Symposium from Nicosia, Cyprus. We now proceed with our first session, Returning to the Moon, the Grand Vision. It features the Director of the UN Office for Outer Space Affairs, the Chief Scientist of NASA, and the former Director General of the European Space Agency. The moderator is the Vice President of the Moon Village Association.
Excellencies, distinguished guests, colleagues, it is an honor for me to join you at this 5th Global Moon Village Workshop and Symposium. Thank you to the organizers for the opportunity to address this event. And allow me first to congratulate the Moon Village Association on all the outstanding work. I follow your efforts closely. As we are all aware, achievements by the international space community are once to marvel about. I cannot be more excited to have been part of the journey. And looking ahead, I am filled with joy and interest for what is to come. While we have ventured far, we are, like the great explorers of the past, striving to go even further. It is, in the end, this never-ending passion for discovery that led us to make great strides. This growing interest in space exploration is great news, even more so that today, unlike decades ago, these efforts are not anymore exclusive to a handful of nations. From many new governments vested in space endeavors, through private sector entities driving innovation, to academia, civil society, and even citizen scientists. The space ecosystem has evolved a lot, underscoring both the interest in space investments and the value of capacity building and collaboration. Soon, the list of countries with at least one satellite will reach 90 entries, a giant leap from 50 only a decade ago. This is a great sign of the democratization in space activities, which translates into facilitated access to space. Seeing the gap between nations gradually diminish in not only encouraging but also game-changing, exploration means not only great accomplishments, but is also delivering the promise of a better future as science, technologies, and innovation translate into countless benefits here on Earth. So, as we look at the future, we must cherish the astonishing plurality in today's space sector. But it is only one part of the story. We still must bring the remaining countries into the equation. The UN has 193 member states, which means over 100 to go. Space is there for everyone to explore. And as it is a public good and global common, we must leave no one behind. As we aim for new worlds, exciting discoveries, and groundbreaking milestones, we must carry the promise of a more inclusive and diverse sector in mind. The moon has been our cosmic companion for billions of years, and as we unlock its secrets, we must do so together, nations big and small, spacefaring and emerging, developed and developing, joined by all other stakeholders. In this context, I embrace the activities of the Moon Village Association. Your continuous work in generating discussions among actors across all levels is a significant step towards ensuring global participation in future exploration efforts. This symposium series is a clear testament of your vision. This is fully in line with the position at the United Nations. We advocate for an open architecture framework, enabling everyone to contribute to one of humanity's greatest adventures. The Office for Outer Space Affairs exemplifies the power of multilateralism. It has been central to anchoring peaceful exploration and cooperation in this arena, and also in expanding both the provider and user base of space benefits. And as the space community's attention turns back to exploration beyond low Earth orbit, we underscore our commitment to serve all United Nations member states and help them on their path. We will leave no one behind. As the Outer Space Treaty says, the exploration and use of outer space shall be the province of all mankind. And with this in mind, I wish you a productive and informative event. Thank you.
Good morning. This is John Mankins, the Vice President of the Moon Village Association, and it is my pleasure to be here with you this morning in California and in the afternoon and the evening elsewhere in the world for this opening session of the 5th Annual Moon Village Association Workshop and Symposium. We're going to begin this event with a rather august group of speakers. Including, if I may screen share, including two names that you undoubtedly know. The first of our panelists this morning is Professor Johann Dietrich Jan Werner, and the second will be Dr. James L. Jim Green. And I'll proceed with their introductions in just a moment. I'd like to ask now if our technical team would please play a short video from the sponsor of this year's Moon Village Association Workshop and Symposium. Please, Glafki. Thank you so much to our team and to Lockheed Martin for being the sponsor this year. We greatly appreciate their support and their participation in humanity going to the moon. So the topic of today's discussion is going to be addressed by two truly distinguished and accomplished leaders in space science and space exploration. Professor Johann Dietrich Jan Werner, past Director General of the European Space Agency, past Chair of the Executive Board of the German Aerospace Center, DLR, and past President of the Technical University at Darmstadt. And Dr. James L. Jim Green, NASA Chief Scientist, past director of the NASA Headquarters Planetary Science Division, and past co-investigator and deputy project scientist on the IMAGE mission, Imager for Magnetopause to Aurora Global Exploration. And I think it's important, the great span of interest and activity and individuals across the space programs who have been touched and influenced by the thoughts and words of these two gentlemen. Today, we are inviting them, and I should mention just in passing, neither of them got to choose what I was going to put onto their bios. I simply went with the accomplishments that I felt were the most important, or which I regard very highly. So you're stuck with them. I apologize. There are lots of other accomplishments that you can also refer to. Today, we will begin to think about the future by looking to the past. And in particular, the subject of our vision, our topic today is returning to the moon, the grand vision. And in line with the thoughts of Jan Werner, I'm going to rephrase that just so slightly and say it's forward to the moon, the grand vision. And I share with you a brief, some thoughts from a booklet that was written as an essay for the Atlantic magazine by two leaders of NASA at the beginning of the space age, Dr. Robert Jastrow and Dr. Homer E. Newell, in 1963, that posed several key questions and then answered them for key stakeholders in the US who questioned why the moon and why so much money. And some of these questions included fundamentals such as why space? And part of the answer, and I really recommend this booklet to you if you have not seen it, part of the answer was that there's fundamentally new science to be achieved in space in creating this new field of space science. Why the moon? Part of the answer was a better understanding of the history of the solar system and the Earth. Why with astronauts? because with astronauts, there was the opportunity to achieve our goals in science and space better, faster, and with more assured accomplishments. What were the benefits to society, the more tangible benefits? Newell and Jastrow identified inspiration, the value of research, technology, and future space applications. We're just at the dawn of the space age in 1963. And what would be the benefits to the United States? And of course, an important part of that was meeting the challenge posed by others. At that time, the competition between the USA and the USSR, and the broader goal of leadership. And the essay is very nicely written and touches on these topics and many others. But I wanted to use these as a way of framing for our panelists the overall topic of going forward to the moon. And so if I may, I will offer the first softball, i.e. what I hope will be an easy question to Professor Jan Werner, and I will ask the question. So what are the, what in your view, and I'm not asking, please don't feel you need to answer quickly, take your time, elaborate, that's why people are here, but not too long, because we only have an hour. But if I may, I'll offer the first question to Professor Werner. Jan, in your view, what are the scientific opportunities? What are the challenges? What are the prospects for humanity's next steps on the lunar surface? Please.
Thank you very much. Thank you very much, John. And hi, Jim, also. Thank you very much that I can participate in today's discussion. And the question, why to go to the moon, was an interesting question in the 60s. And it is still an interesting question today, because citizens have the right to ask that question. And scientists have the right to ask that question. And politicians who are using citizens' money have also the right to ask that question. And there are several reasons. And the reasons might be different from country to country, from person to person, from different ages, so whether you are young or old. And I learned that the difference in the view is already something which I like to hear. There should be not a unified answer to that question. So I cannot tell you the real answer to your question. I can give you my personal opinion. This is the difference. But I think it's important that we have different personal opinions for that. But at the end, the goal should be the same. Then it's fine. So why to go to the moon from a scientific point of view? I was coming to space, so to say, in 2007, when I was elected chairman of the executive board of DLR. And my very first meeting with the international community was with the ESA Council. And I was sitting in a dinner together with my Italian colleague, Nanni Bignami, who is was a great scientist. And he knew that I was fond of the moon, going to the moon. And he said, is it right what I heard, that Jan, you are trying to have moon missions? And I said, yes. So he said, this is a stupid idea. From a scientific point of view, this is just a dead rock. There is nothing to discover. We know everything. Now, only a few years, I should say, 13, 14 years later, we know that there is a lot of things to be discovered. So there was found that there is water on the surface, on the moon, not at the surface like on Mars, but there is water on the moon. There are other resources, other minerals, other materials on the moon. And it is said that the moon is something like the archive of our history as well. So there is a theory, nobody of us was witnessing it directly, that another body was hitting the Earth, and by that the moon established. And that means, as we have no earthquakes on moon, I mean no big earthquakes, no moonquakes, no big moonquakes, which are really changing the surface, etc. We have no flowers, no animals. So the moon is something like an archive, a very special archive, because it has something about the history of the Earth, but also something of the history of what can happen to a body which is impacted permanently by different smaller bodies. So it's a very, very special opportunity we have with the moon. And there are more things. So there are scientists thinking about a radio telescope on the far side of the moon, and all of these different aspects. So there are enough reasons, just from a scientific point of view, to go and discover more of the moon.
Thank you, Jan. And if I may, I would turn next and ask the same question, pose the same question, if I may, to Jim Green. Jim, what are your thoughts?
Well, I really like the idea in the pamphlet that they started out with a new field of science, of discovery. And now we're essentially on the other side of the initial examination of looking back at the lunar Apollo rocks, all the missions that we have there, and then do an assessment of where we are and what we need to do next. And I can tell you immediately that it has revolutionized our understanding of the Earth-Moon origin. The moon has the basic witness plate, as Jan mentioned, of that history all over its surface, because it doesn't have a biosphere, doesn't have an ocean, doesn't have the interactions and plate tectonics that the Earth does, that has destroyed that past record. And so understanding the age of the Earth really came from looking into space, looking for the material, particularly from the moon, of the 4.5 billion year old rocks and the material that are there. Whereas the oldest rocks here on Earth we can find are about 3.8 billion years. So it already has given us a basic foundation of putting an answer to how old the sun is, how old our planets are, how old the Earth is in a context. Now we want to start filling in the details with many more missions that can go and interrogate the surface and look at it. The moon is close. It has all kinds of information in terms of impacts by comets, in terms of impacts by asteroids. It has a collection of material that has been created in many different places in the solar system, and therefore it has resources associated with it laying on its surface. So scientifically, it is tremendously exciting. You know, a mission that I was very intimately involved in and funded, which was the Lunar Reconnaissance Orbiter, which is still orbiting the moon, making high-resolution images of the moon, and its associated LROC mission that impacted these areas in the South Pole, blasting up material that's caught in these permanently shadowed regions, changing our thinking completely about the resources that are available on the moon, because it dug up methane and ammonia and a whole series of simple organic material, telling us that the permanently shadowed regions also contain a history of lunar volatiles. Now, that's extremely important from a scientific point of view, but now it forms a new basis for us to be able to go and explore this surface. Now, it's not like going to a planet that has all these, you know, water and atmosphere, et cetera. It's a different environment, but we know enough about the environment now where we can go and live and work on a planetary surface, and that first surface will be the moon. It's just an enormous resource for us, and we have so much more to learn. It's just the start.
So thank you, Jim. And I think this is an excellent beginning to our conversation and to this year's event. I think as in the opening video, as Giuseppe Ribaldi, the president of the MVA, pointed out, over the next year and over the next decade, there are going to be scores of missions and investigations carried out near and at the moon, and it will be of tremendous impact, I believe, to the future of not just space science, but philosophy and other fields. So if I may, let me turn to a slightly different and I think important aspect. And this time I will start with Jim, if I may. So Jim, you're still on the hot seat.
Sure.
And in particular, let's, if we could, speak a little bit about the international benefits, opportunities, the importance of the international participation and engagement this time in lunar programs. So please, your thoughts.
Well, indeed, a new opportunity for us has arisen, unlike the past, where indeed, as you pointed out, going to the moon was US and the former Soviet Union and funded completely by those countries. Now, with an era of expanding the space agencies around the world, we have an opportunity to partner. And indeed, we're excited about our partnerships. We have worked so well with the European Space Agency and the Japanese Space Agency and even the Russian Space Agency. It's a collaboration now that has gone on for decades, and we need to make sure that we preserve it and continue. You know, I feel strongly about this opportunity for humanity to be able to explore our solar system. And the start of that was NASA produced a few years ago the Artemis Accords. What are the guiding principles that will help us work together? These are based on the Outer Space Treaty. But what was really exciting to me is they added a couple new dimensions to that. One new dimension is declaring heritage sites. Now, I love history, and so this really resonated with me when I became head of planetary, and the Google Lunar X Prize was all about going to the moon and sponsoring and getting commercial entities to be excited about doing that, but having them go to former Apollo sites and take pictures and do things, and you get extra money. To me, I was a little apprehensive about that, knowing that NASA, when it first started trying to observe the moon, it lost mission after mission. I mean, we couldn't even hit the moon, you know, let alone be able to land specifically in an area. So I felt concerned that we could destroy what would be history, a history-making opportunity. And indeed, I can imagine in the future a museum centered around some of these historic sites. Now, to the US, that of course is going to be basically the Apollo sites, Apollo 11 for sure, that we want to be able to preserve. But in 100 years from now, when there are people living and working on the moon for months, maybe for years, the entertainment they may have may be to go down and visit these heritage sites, because no one at that time would have been alive to have seen them. Now, I was in high school. What got me so excited about space, not only was the era of Star Trek, I watched the original Star Trek. In high school, I was involved in telescope observations, astrophotography. But of course, the lunar landings were so exciting. I mean, to me, those people that haven't seen it are young people coming out today, and those in the field even are in for a treat when we see our humans living and working on the surface. When we first land in the South Pole with the first human being a woman, the next astronaut on the moon. This will be tremendously exciting and galvanizing, I believe, to enhance our international participation. So I think we're just at a wonderful opportunity for humanity of the world to embrace it. Even though Neil said when he stepped out and felt that indeed this was one step for humankind and meant it, now we can live it.
Thank you, Jim. And if I may, to Jan Werner. And I deliberately did the order this way because whereas Jim grew up in the bosom of a national space program, Jan, you've lived the reality of knitting together dozens of countries into the European Space Agency. So please, your thoughts with regard to international engagement and the importance of it for the moon.
Yeah, thank you. First of all, especially like Jim was saying, the landing on the moon, of course, I followed all of that. I was inspired already in 1957 when Sputnik was launched. My father took me on his arm and said, "Look, Jan, there is a satellite." I could not see it, but because your father tells it you, of course, you see something. And afterwards, I followed all the programs. And so the situation is, of course, everyone believes that it was a competition in the Cold War. Who is the first, which flag is the first on moon. And it's interesting, the competition was between Russia or Soviet Union and the US, and the winner was Switzerland, because Switzerland had the very first flag on the moon, this flag for collecting solar flare. So therefore they were even before the American flag, because the astronauts had to place that first. So now, of course, America was winning, but I think it's a nice part if one can use. So I was always looking also for the international situation of space, and as ESA, having 22 member states directly involved in ESA, of course, it is international, and therefore I always tried also to convince other states in the world that space is something where we can unify, where we can work together. You all know Simon and Garfunkel bridge over troubled water. And this is what I believe what space is. Space is a bridge over troubled water, and troubled water meaning nationalism, sanctions, power games, etc. In space, we are really geographically above all these borders. And therefore, for me, space is really a possibility to work together. And therefore, looking to the moon, you mentioned it already, I'm always trying to say, let's not ask for back to the moon or returning to the moon, because that could mean we do the same what was done 50, 60 years ago in competition, in a race in space. This time, I believe it's time to do it together. And it is planned to do it together. And the Artemis program is a program of working together, with different levels, of course, but it's open. And this is, for me, the beauty of the Artemis program. And of course, the second beauty of Artemis is the name itself, being the twin sister of Apollo. But okay, this is another story. First of all, I'm happy that we have this opportunity. And therefore, I say, let's go forward to the moon in an international understanding, which does not mean that the different nations cannot have their own interest. It is, the moon is there. It's not owned by this or that country or this or that company, and therefore it should be open for all the different players, be it public players or also private players. Of course, we have to follow some rules. The question remains, must these rules be written rules, or can we based on ethics and moral? So not destroying the moon, that we have half moon all the time only. So we should really be happy that we have a full moon also sometimes. And therefore, I believe the moon is a very nice place to work together beyond our earthly borders. And this is what I always tried to support.
Thank you, Jan. I could not agree with you more. So from the cerebral, the scientific.
I forgot one point, if you allow me.
Please.
Because Jim mentioned the heritage of the different sites. What I could do, if I would go to the moon, I would take a fresh set of batteries and take the rover over there and go to the different sites. Maybe that's a good idea.
Yeah, there are a couple available.
Yeah, exactly. Used cars, huh?
Very reasonably priced.
Yeah.
Yeah, well, no, they'll be expensive because you have to
Yeah.
get there to see them.
Exactly. Okay, so we've talked about the cerebral, the science. We've talked about the international implications and the opportunities for cooperation. If I may, I'd like to ask if we could turn next to the tangible benefits that might come from our journey forward to the moon. And if I may, Jan, I'd like to begin with you. You said during our preparation call that you're only an engineer. So it's not true, but as an engineer, and because of the role that you've played in German universities and scholarship and engineering, let me ask you the question, or pose to you the topic. What do you think will be the tangible benefits? When I say tangible, I'm including the broad range of benefits that will come, not just a new breakfast drink.
Yeah. So as a Director General of ESA, I always said we have three addressees of what we are doing in space. Number one is the society at large, and also the individuals. Number two is the industry, the economy. And number three is the environment on the surface of the Earth as well as around the Earth. Now, if we look to the society aspect, the question is always, what is the benefit of space? And then, of course, the Teflon plate is mentioned, and the Teflon pan, and said, no, it doesn't come from space. This is the common approach to that. There are so many things. It's not necessary to list all these aspects of transfer from space to Earth, the solar cells, the fuel cells, and others. We don't need that. It's important to give the information to the public, but in this discussion, it's not necessary. And it's also not necessary for me to show that the investment in space get a return. So we made that in ESA. We calculated that the return of investment is a factor 1 to 6. So €1, $1 invested in space, you get back 6 overall in all the different disciplines. Of course, it's in some areas it's stronger in Earth observation, in others it's a little bit weaker. Let's say in human spaceflight it's only 1 to 2, but in any case it's above 1 to 1. So this is the monetary approach. But for me, another approach is very important, and this is we are living right now in a time of crisis. We have the corona crisis, we have the climate change, and there might be other crises in the future coming up. And what is necessary in those crises is that you have people who are looking forward, who are motivated to really use themselves and use their competence to develop the future. And this motivation does not come automatically. Motivation in our body in our brains needs some fertilizer, maybe some fertilizer. Okay. I don't know what the best word would be, and I always found that space is fascinating people. Whoever you ask, space is fascinating. Even people who are saying I'm against space, but they are fascinated. It's Star Trek, it's in movies, it's in the reality. So space is fascinating. Fascination is just something like joy in our brain. It's a positive movement in our brain. So nothing more than that. It's not a thinking about it. It's just happiness and okay. Now the next step is using this fascination and think about it, getting it into a more conscious understanding, and I call that inspiration. And if you have inspiration in your brain, the next step is to be motivated, to have motivation. And this is a very key aspect for me. This does not mean only motivation for space. You can be fascinated by space and you end up to be a civil engineer like me. I was fascinated by space. I was inspired by space. But then, according whatever the reasons were, I was educated as a civil engineer. And I was very much motivated to do something for the society, to do something, to create something, and all of this. And I believe this is a very societal approach to space, but I think it's really true. People who are fascinated and inspired can be motivated. And this is what space really can deliver for the society at large.
Yeah, I would completely agree. In fact, John, that early pamphlet from Nagel and Jastrow was right on. You know, inspiration. There it was, and all you have to do is look back as how the Apollo has inspired a new generation of scientists and engineers and many other disciplines actually to work towards going into space, supporting the space programs, and developing new technologies. The concept of thinking out of the box. Well, we don't know how that will apply here on Earth, but in space we need this. How do we develop it and work it? And then from that, all of a sudden things can be leveraged and used here on Earth in important and unique ways. Right now, you know, we're building new space suits. We're building new approaches for sustainability. We're recognizing that the surface of the moon has all sorts of material. So how can we leverage that and use it? So 3D printing, for instance, is another huge technology moving forward. We also recognizing that if we want to live and work on a planet, we must do it in a sustainable way. That means everything we take up will be valuable. Everything from packaging the food after you take the food and eat it, the package must be reused. We must think about how to recycle that, melt it, put it in 3D printers, use it as another element, because every pound that we take up is so precious to us that we can't just throw it away. The concept of recycling, the concept of saving the resources that we must do in space, we must do on Earth. And so these are also important new concepts that we want to forge ahead on. And I think there'll be just tons of benefits to society as we go along. And as we've continued to see that happen in the past part of our programs.
Yeah, so space can be a driver of circular economy in a very broad sense. And I believe this is very important that we do that. And next time we go to any other body, whether the moon or Mars or whatever, we should use what is there, because that's much better. And as you said, Jim, then also to look how to reuse things and not throw it away.
Yeah.
So together, the both of you seized on my fourth topic and have talked it through rather thoroughly. But I want to go one step further on this question of sustainability, because it is new under the sun. It is one of the accomplishments of the UN Office for Outer Space Affairs. This idea that the moon must be sustainable, space must be sustainable. It cannot be denied that one of the principal motivations for a lot of new interest in the moon, going from one mission every 3 years to 5 missions in 1 year, is stimulated by the lunar ices, by the lunar resources, by the idea that the moon might somehow become part of a larger Earth-Moon economy by many, not everyone, but by many. And I don't really want to get into a discussion about, cislunar space and the great game and all of these things. That's for other forums. But I think that this idea, this question of how to best use the resources of the moon for the tangible benefits to humanity, and to do so in a way which is sustainable, that these are, and a way that shares the benefits, and all of these things that we've already touched on so far. But with regard to the resources of the moon and their utilization, I'd like to turn back to that. And Jan, if I may, I'll give you the first crack at the ball. How in the world do we manage all of that in a way that is compatible with the critical topics and opportunities we've talked about, including sustainability?
Yeah. So it's very easy. Huh? You just have to look to the SDGs, the Sustainable Development Goals of the UN, and whenever you do something, you have to look whether you are following these SDGs or not. Now, this is a naive, simple answer, and I'm a little bit naive in that respect because I'm not naive by accident, but by really my understanding. If we are waiting that somebody is writing a full law for the moon, everything included, and this is internationally accepted, how long would that take? It would take decades. Yeah. And even then, some countries also would not accept. So I believe it's the same like with space debris. It's the same question, how to write a regulation for that. So the better solution is that the good ones start in the right way. And I'm quite clear. If you are doing permanently the right thing, the others will follow. Not immediately, but the good ones will win and the good things will win. And therefore, I believe that whoever goes to the moon next should really consider it and look for a sustainable solution for whatever he or she or it or whatever is doing. This would be my solution. It sounds naive, but after all, I believe this is the one and only solution. If you say, I wait until we have a regulation, and until the regulation, I do whatever can be done, then you are not paving the way for a good solution. I don't know whether you could understand me, but this is what I believe.
Yeah, perfectly.
Well, fortunately, I think we've got a good example, several good examples that we use here on Earth, how we use the resources of the ocean, how we work together internationally in Antarctica. So how we work well together, in low Earth orbit, particularly on space station. So I think those bode well. That they come out in a very productive way, and in a way that continues to unite the world's populations with different cultures and backgrounds. In fact, the different cultures and backgrounds portion is critical, I believe, in the concept of diversity and what we've seen with diverse backgrounds, people coming together to tackle solutions. So I think this next stage of space exploration being done on an international basis will really help that. Now, the moon, in terms of sustainability, has got all kinds of great things going for it. When you think about going into an area here on Earth and you need construction materials, construction aggregates, it's called. We mine and we do things, but on the moon, we have already some construction aggregates. It's the regolith, and it comes in different sizes, and it's easy to acquire because it's everywhere. It's easy then to we believe to manipulate and create cinder blocks for construction. Jan's picture is perfect for this. It's just the concept of using that environment to create the protective areas, to create that first outpost, and learn how we can use those materials. So we know a lot about them because we have acquired them for the Apollo program. We have more than 850 or so pounds of lunar material, including regolith and rocks, and even tubes of stratigraphy that we've jammed into the surface to get material brought back. And we haven't opened all of it, but we've really interrogated that archive of material. And I think that next big step in terms of sustainability in using those resources are being thought about internationally through in situ resource utilization instrumentations. And of course, the materials like the water. When we get to the South Pole, we know about the water because we've remote sensed it. We believe there's hundreds of millions of tons of water in more than 300 permanently shadowed regions in both the North and South Pole that we've cataloged, but we haven't got ground truth yet. The only thing we've done through LCROSS is to get a taste of what might be there. But indeed, I think we're going to find that there's probably a lot more material than we'd ever imagined, a lot more volatiles that then can be leveraged and used. So this is just going to be a really exciting next decade.
But because you mentioned the shelters for the astronauts, I think it's also important that we agree on this situation that the moon is not a better place to live. The Earth is a better place. So yes, that's very important for me, because sometimes people believe, yeah, we send about thousands of people to the moon and they stay there for life. This is not a place for life. It's a place for research. It's a place for scientific working. Let's say a month or 2 months or even years, that's fine, like on Antarctica, but it's not a place to live and die over there. That's for me not a good solution.
Yeah. So I'd like to, if I may, I'd like to jump in here before you steal my next topic. So Professor Werner, Jan, you're an engineer by your own self-acclamation. Jim, you're a physicist, a space scientist.
Yes.
My background is in physics a long time ago, but I think we would be remiss not to speak a little bit about another major discipline which is benefited from space and is an important part of this future for humanity and the extension of the Earth's biosphere into space. And this goes to the idea that 1 point makes 1 point. 2 points define a line, but it takes 3 points to define a curve. With regard to gravity and the role of gravity in biology, we have a huge trove of data over millennia on 1G. We have a few decades of information on 0G, or very close enough to 0G that it doesn't matter.
Right.
With the moon, we will suddenly have 1/6G.
Mm-hmm.
And what might be the consequences for the biological sciences, it seems to me, is equivalent to the first telescope, first optics looking at the heavens, and suddenly Galileo discovers there are moons there. Who knew? So Jim, if I may, so what about the biological sciences?
I think your point is really important, and that is we have those end members. What will happen in between? One of the exciting things that are going on right now is what we found out with astronauts that have come back from space station, is that the longer they're in space, the more their immune system becomes compromised. So a 40-year-old returning from space who's been in space 6 or more months may have an immune system like a 70-year-old, okay? It ages. But we also find that they rapidly gain that back. We don't know how and what some of the physical processes that compromise that immune system, and we don't know how the individual has brought it back. This is important physical research to do, human research to do. What will happen in 6G? We don't know. This will be a critical thing for us to explore and examine. That process may go slower, but it enables us to then tease it out, to be able to understand it. This is just one of a myriad of things that we'll also have the opportunity to explore. But our elderly, 20% of the elderly die of pneumonia because of a compromised immune system. If we can understand how to to keep our immune system up. And I use this example because of the COVID environment we're currently in, and how the immune system handles these things. This is a fundamental research area that can reap enormous benefits to indeed tackle things like things that attack our immune system, and age being one of them. Keeping it sharp, keeping it available, keeping it, enabling us to fight all kinds of things from COVID to malaria, etc. So these things will be really critically important for us to do. And I know we want to do that. I know we're planning to do that in this environment. So we will learn a lot about how humans acclimate to that 1,6G, and we'll know what the targeted areas we want to look at, because we've seen that end member change being in microgravity.
So what I learned from that point of view is that the immune system, if you are in 0G, suddenly reduces. So is it the same if you are at 1,6G? This is really an open question. And because it might, sometimes I'm asked also by politicians why to do human spaceflight. And I said, okay, please measure the blood pressure of a robot, or measure the immune system of a robot. This is your example. And this is really something which is very important, but it's also for me an opportunity to quote Werner von Braun, because we are talking about gravity. You know this very famous quote, but I like it so much. Our two greatest problems are gravity and paperwork. We can lick gravity, but sometimes the paperwork is overwhelming. Now we are saying also gravity has some more secrets to be seen.
Very good, very good. So we're coming close to the end, and I want to have enough. It's been a fast hour, a fast 50 minutes. I will hold off for just a moment. I'll give each of you a chance to say your parting thoughts, your closing thoughts in just a moment. But first, I wanted to come to another topic, back around to the question of the international. And I'll just say that within the Moon Village Association, because we are not a body comprising government space agencies, we have a very broad membership, space agencies and companies and people, individuals and companies and universities. One of the things that I have noticed, which is very distinct from my perspective of 35 plus years in the business, is the degree to which the non-traditional players, emerging space countries, emerging new space companies, the way that they are all excited and interested in this this venture to the moon, to phrase it that way. And so, Jan, let me start with you and just say, what do you think about the engagement and the participation of emerging space countries in particular, but the emerging space community, and what it represents?
It was in a discussion at Colorado Springs that I had a discussion with a journalist, and I told him the idea of a multi-partner open concept on the moon. Multi-partner open concept. And I explained to him, multi-partner means for me public and private, different institutions worldwide, etc., etc. Open means it is not a fixed number of participants, but it's open. And concept means it is not one mission, but it is a concept, an overall concept for some time. And he told me, Jan, nice idea, but the word is terrible. You need a better word. And that was the basis for Moon Village. The problem with Moon Village was that I got immediately some emails, people who wanted to become a mayor of that. So let's go forward to the moon in a multi-partner open concept Moon Village.
Jim.
Well, from my perspective, NASA's really embraced this commercial sector portion of it. In fact, we have plans over the next several years to work with many different commercial partners, more than 9 or 10 commercial partners, I think is the number, for which we have now contractual agreements with. We now have plans for them to deliver packages scientific packages, not only in the South Pole of the moon, but also in other locations on the moon, for us to learn more about the moon based on our current understanding. We want to build on that. Now, that's going to help in many different ways. It's going to bring many engineers and scientists into those commercial companies. It's going to create a new economy of space where they can take those results and use them in building the next generation capabilities. You know, the way we progress in terms of our technologies is to create investments, yes, and do fundamental research, but the end result makes critically huge steps, and that is proving those technologies, moving them from concept all the way up to implementation. You know, the technology readiness level that NASA uses, you know, TRL levels, they're called, from 1 to 9, is an important framework. And to have many of these companies develop new ideas and capabilities and move them up that concept tree all the way up to reality is an enormously important, huge step. You know, you know, you have to be able to think about our future, or you don't have a future. And that means you have to execute what you've been thinking about and planning and developing over time. So it's going to be tremendously important, I think, worldwide as we continue this partnership, not only from our international partners, those that have now become more space aware, want to be able to join the Artemis Accords and participate in this in their own abilities and ways, but also those commercial companies. So it's a really exciting time.
So we are down now to our last couple of minutes. And I must say, I really enjoyed our conversation. I hope the same is true for the audience.
No, for me at least.
Yeah,
Jan, if I may, I'm going to offer you, Jan, if you would, in a minute or so, any final thoughts about the future and the moon? Go forward to the moon.
Forward to the moon. You see, I give another quote with Saint-Exupéry: we should not foresee the future, we should make it possible. And I believe this is a good message for the moon. The moon is there. It waits for us. It will leave the Earth some days, so we better rush and go to the moon.
Jim, the same to you.
Well, for me, you know, one of these Apollo babies, I guess you would say, where we watch the humans step on the moon and walk around and deploy instruments. And those people that haven't been alive during that time period are really in for a treat. I mean, I watched it on a black and white grainy TV and I was excited. We're going to see it in high definition, and it's going to be so much different. Instead of the sun overhead, it'll be to one side. It will be, you know, eerie shadows and really give us new and unique perspectives. So I think that the inspiration part of it is something that the world will embrace and come together and see what will be happening. Indeed, we're increasing our robotic missions, as I mentioned, but NASA is involved in thinking about 10 Artemis human missions now, well beyond the first one, Artemis 3, which will be indeed setting down on the moon. So we have all kinds of exciting plans over this next decade. So this is going to be the decade of the moon. Sit back and enjoy it, or join us. Come along for the ride. See what you can do to help participate. Get involved in those companies and really support your nation's goals to participate in this grand adventure. It'll be worth it.
I'm ready to go.
All right, I'll sign you up.
So with that, I will draw our panel to a close. I will take exception on only one thing that Jim said. This will absolutely be the decade of the moon. But I believe more than that, just as the 1950s were the beginning of the space age, I believe we are just now at the doorstep of the moon age. Because I think once we do what we're planning now for the moon, we will never pull back, not again. The moon will be now forever part of humanity, human science, human enterprise, human thought for the rest of civilization. My opinion.
I agree completely, and I think we're at a stage you can't stop it. Let's do it.
Right. Let's do it. Let's do it.
Yeah. Okay, gentlemen, thank you so much. I look forward to seeing you at during the rest of the conference, and absolutely to seeing you soon on the moon. Take care.
Merry Christmas. Bye bye.
Bye bye.
Merry Christmas. Happy holidays.
Yeah.
中国国家航天局与俄罗斯国家航天集团公司已联合发布了国际月球科研站项目路线图和合作伙伴指南 1.0 版。国际月球科研站是中俄贡献国际社会的重要合作平台，为人类空间科学探索和航天能力验证提供团结互助的合作机遇。月球与深空探测是人类空间活动的重要组成部分。中国国家航天局愿与各国加强广泛交流与合作，共同推动外空活动的可持续发展。谢谢。
Good day to all and warm greetings from Indian Space Research Organization. I am happy to be a part of this August gathering and share on ISRO's missions to Moon, which are science-driven but will also provide valuable scientific inputs for establishing lunar settlements in future. India's journey to the Moon started with Chandrayaan-1 in 2008. With the remarkable scientific success of Chandrayaan-1, a more complete follow-up mission was configured. Chandrayaan-2 mission was designed with an orbiter, a lander, and a rover to pursue global lunar mapping and initiate in-situ studies in and around the landing site. The hard landing of lander prevented us from pursuing in-situ science. However, I am glad to inform that the orbiter will have extended mission life. I feel happy to mention to the lunar science community gathered here that the orbiter successfully completed 2 years in orbit around the moon. The data obtained from the science payloads on orbiter are of excellent quality, and part of the data sets are already released to the public. In order to demonstrate landing and roving on the lunar surface and to complement Chandrayaan-2 orbiter science with in-situ observations, the Chandrayaan-3 mission is now planned. The science which we are planning in Chandrayaan-3 mission is aimed to study the thermophysical properties, seismicity, and elemental composition in the vicinity of the landing site. The spacecraft will have landing module with a rover inside the lander. Chandrayaan-3 lander is expected to soft land and in the unexplored southern high altitudes on the moon. The mission life is around 14 Earth days. The rover and the payloads on lander and rover are similar to Chandrayaan-2 mission. After landing, the rover will roll out of the lander and perform in-situ observations. The mission is getting ready for launch in the year 2022. ISRO is also gearing up for the exploration of the volatiles in the lunar South Pole jointly with JAXA in the LUPEX mission, which is planned to launch in 2024 timeframe. With this, I conclude saying that ISRO plans to have a combined observations of remote sensing from Chandrayaan-2 orbiter and in-situ studies using Chandrayaan-3 lander and rover. These scientific observations will provide valuable inputs not only for the scientific understanding of the moon, but also to plan for lunar settlements in future. I take this opportunity to wish success for all the future missions discussed in this session. Thank you all.
Dear participants of the 5th Global Moon Village Workshop and Symposium, it is my great pleasure to address you today. I'm Sasaki Hiroshi, Vice President for JAXA for Human Spaceflight Technology and Space Exploration. I'm grateful to have the delightful opportunity again to virtually participate in the 5th Global Moon Village Workshop and Symposium today. In the midst of the challenge circumstance of the worldwide COVID-19 pandemic, people across the world have made tireless effort to hold this prestigious event. They all deserve our high respect. Especially, I would like to express my deep appreciation to MBA President Dr. and host of the event, the Cyprus Space Exploration Organization. Taking the worthy opportunity, let me introduce you the recent developments on lunar exploration in Japan. Last year, the government of Japan signed a Joint Exploration Declaration of Intent for Lunar Cooperation, the Artemis Accord, and the Gateway MOU. Accordingly, JAXA is preparing for cislunar lunar surface missions, utilizing the technologies obtained through the human space activities, including the International Space Station (ISS) program, and knowledge gained through various space science missions. For Gateway, JAXA is planning to contribute habitation capability demonstrated at the Kibo module and logistics resupply capability using the updated HTV resupply vehicle. For lunar surface, we are developing the smart lander for investigating moon SLIM to demonstrate precious landing. In addition, under collaboration with the Indian Space Research Organization, ISRO, JAXA is preparing for the Lunar Polar Exploration Mission, LUPEX, to study water resources in the lunar South Pole region. JAXA is also engaging in numerous dialogue and investigations with private companies to establish sustainable human activities on the lunar surface. Correspondingly, we are jointly studying with a Japanese company on a pressurized crew rover to enable lunar surface exploration over extensive areas. Furthermore, to future development of moon base, JAXA is conducting various joint studies with private companies in many areas, including constructions, fuel plant, agriculture, and food. Collaborating with Japanese private companies, which possess unique technologies and advantageous knowledge, we aim to contribute to the development of essential assets for sustainable human activities on the moon, such as constructing and living on the moon. At the same time, we firmly believe in the importance of providing the benefit and innovations to our life on the Earth. In addition to the global coordination, having broader engagement of the industry and academia is a key to establish sustainable exploration. I'm looking forward to the various discussions at the 5th Global Moon Village Workshop and Symposium among experts and professionals from all over the world, yielding valuable knowledge to realize sustainable human activities on the moon. And especially, I strongly expect that those discussions will inspire young generation. Lastly, let me conclude my speech, sincerely wishing you success of this workshop and symposium. Thank you very much for your attention.
Hello everyone. I express my gratitude to Professor Giuseppe Ribalde, President of Moon Village Association, for his kind invitation to participate in the 5th Global Moon Village Workshop and Symposium. The most important question from my point of view is not only the return to the moon, but what the human being wants to develop on the lunar surface. And it is here where rules for sustainable development will have to be established in a coordinated manner and based on cooperation. Some guidelines were established by the Hague expert groups on mineral resources. Others are the subject of elaboration within the Committee on the Peaceful Uses of Outer Space, COPUOS. We have discussed others within the MBA work, such as best practices for sustainable lunar activities, which obtained the opinion of various stakeholders. A number of issues must be addressed to assure sustainable lunar exploration and settlement on and around the moon, including, for example, mitigation, the creation of debris in lunar orbit, defining standards to enable interoperability and regulating access to natural resources, an issue addressed by MBA in 2019, creating an international platform to address these critical issues with the aim of eliminating the risk of future lunar missions and increasing global cooperation for lunar exploration and settlement. The Mexican Space Agency has developed some space exploration projects, and others are in process. Likewise, to specify and venture into new projects, we work in alliances with other space agencies and academic institutions and industry. To this day, I can mention the HIGH project, sending 9 rovers to the lunar surface, carried out jointly with the UNAM and the support to the CONACYT Fund and the Mexican Space Agency. The mission work schedule for this year, however, derived from the pandemic, it will be launched until the end of May 2022. Also, a project is in process to carry out a joint test through the collaboration of Airbus Defence and Space, GmbH, and the REOM Labs, whose objective is to contribute to the growth of Mexican industrial capacities and contribute to international cooperation on the issue of in situ resources. It is a 3-year project, and the test will be carried out in the first stage on Earth and at a site like the lunar surface, and in second stage on the Moon. The Mexican Space Agency assumes the commitment of the peaceful use of outer space and of the Moon and other celestial bodies, and undertakes to do its best to reach a binding treaty that establishes an equal stage for all. Thank you.
Dr. Ribaldi, President of Moon Village Association, Mr. Danos, President of Cyprus Space Exploration Organization and Chair of the Local Organization Committee of the Global Moon Village Workshop and Symposium, distinguished speakers, participants at the 5th Global Moon Village Workshop and Symposium, ladies and gentlemen. Good morning and welcome to this annual symposium discussing the future of Moon Village exploration and settlement. I want to begin by thanking the Moon Village Association and Cyprus Space Exploration Organization for the prestigious invitation to participate in this space agency ratings session. It is an honor and privilege to share my thoughts on the current activities and discussions on the sustainable global lunar exploration, and to participate in the international and domestic committees for future discussion, including experts from the industry, governments, and academia interested in Moon Village Association activities. On behalf of the Egyptian Space Agency, I would like to sincerely express our extended support to the recent well-known accomplishments and valuable contributions for the activities, initiatives, and collaborations towards the future of Moon exploration and settlement, and extend our warm congratulations on the proclamation of the International Moon Day on July 20th, the anniversary of the 1969 first human landing that has been endorsed during the United Nations COPUS 64th session on September 2nd, 2021. The Egyptian Space Agency joined the Moon Village Association in December 2020. The Egyptian Space Agency was keen on being part of the global expert group on sustainable lunar activities, which acts as an international platform to address critical issues such as safe operation, debris mitigation, access to natural resources, and so on, with the goal of de-risking future lunar missions and increasing global cooperation to ensure sustainable lunar exploration and settlement in and around the Moon. Moreover, Egypt was particularly interested in taking the opportunity of participating in the Moon Village Association program to strengthen national, regional, and international cooperation, raise public awareness about space exploration and space applications, ramp up capacity building efforts, involve the next generation of space leaders, and engage the general public in space activities. At that moment, for the further exploration of lunar surface and establishing a permanent and sustainable human robotic presence is the next objective, and collaborations between nations is the ultimate way to reach superior goals for humanity in space technology. Therefore, we are encouraging the involvement of African and Middle Eastern countries in lunar exploration activities through investment on education, outreach towards the youth. Thank you for your attention, and I look forward to the fruitful discussions and projects that will be part of this symposium.
Dear participants of Moon Village Association, my name is Lev Zeleny, and I am in charge of automatic part of Russian lunar program. I'm very happy to welcome you. This is very important activity. We appreciate it in Russia, And I hope Russian youngsters, young scientists, students, schoolboys also will join to it. But I'm speaking now on behalf of older generation, and I want to inform you that we begin in Russia very interesting and prolonged lunar program, and I hope you will hear some first results from it already next year. In Soviet Union, it was a country before it started to be called Russia, we have very advanced lunar program, and was famous competition between United States and Soviet Union in lunar exploration. Americans sent Apollo astronauts, Russia sent 2 rovers, automatic machine moving along the moon, and distance was quite large, about 40 kilometers, and 3 sample returns. And the last mission was named Lunar 24, and was very old time ago, 1976. And next year, 2022, we plan to launch already a second stage of our lunar exploration, the mission Luna 25, which will land in the polar regions of the moon and study specifics of this region, and study volatiles in this region, and will probably prepare the place for lunar village, because we expect to find the water underneath the regolith of the moon. And this is a speciality of polar region, both northern and southern, but southern polar regions, they have more abundant supply of water permafrost. Let's see what happens, and enjoy your meeting, and I try to participate as much as I can, and hope one day we will meet also on Russian soil, and have some real plans for international lunar villages. It's very important. We call it in Russia moon is the 7th continent of the Earth, and I hope we have collaboration, international collaboration in lunar exploration, also very advanced and comparable to what we have in Antarctic, 6th continent of the Earth. Enjoy your meeting. Goodbye.
This concludes session 2. We now have a short commercial break with messages from our esteemed sponsors.
Our purpose in this life is a precious gift. This gift is often waiting to be unearthed in the why of what we do and believe. Our purpose is found in the why of protecting what matters most.
The town of Newcastle, Oklahoma is giving credit to an early warning severe weather forecast system for saving countless lives.
Sir, our satellite alerted us to an avalanche. It's imaging the area and tracking heat signatures of potential victims. Sending updates now.
Our purpose is found in the why of connecting to each other, around town and around the world.
And the U.S. Space Force continues to modernize today's GPS satellite constellation with new, more powerful GPS-3 satellites.
General, this is Air Force One. We will be connecting you to a secure line to the President shortly. Stand by, One.
And our purpose is found in the why of exploring what lies beyond.
NASA's InSight lander has measured the first ever Mars quake inside the red planet.
OSIRIS-REx completed a daring 2-year mission, studying and collecting a pristine sample from the asteroid Bennu. Scientists are hoping to discover insight into the origin of our solar system.
Our why inspires us to protect, connect, and explore, today and for generations to come.
It's really something else. I can't believe we're here.
Unearthed long ago, the why is what gives us our purpose. A mission to advance the human race into the dawn of a new space age.
Mars Base Camp, this is Lunar Control. You are a go.
You're cleared to proceed to Mars. Go make history.
Throughout history, mankind has seen its future written in the stars. Today, that vision of the future is a reality, one which transcends borders. In Luxembourg, we believe in the visionaries and the makers. Here, we support the future space economy as it grows and develops. Investing in people, encouraging research and development, and providing access to financial solutions. Luxembourg stands behind the ones who make and do. Each day brings new ideas and discoveries. We build the tools and provide the services that enable us to grasp our future. Home to the global leader in satellite communications, we operate a unique constellation of satellites that encircles the world. We analyze data gathered from the vastness of space. And we nurture a growing, sustainable commercial space ecosystem, one that connects billions of people, businesses, and everyday objects anywhere at any time. An ecosystem that allows us to understand what's happening on our planet, helps us explore new frontiers, and extend Earth's economy into deep space. Here we believe in the entrepreneurs, the scientists and engineers who put the universe within our reach. This is what makes Luxembourg the place for space development.
For centuries, it's been a gateway between East and West, between past and present, between cultures, old and new. Between tradition and transgression, between ambition and execution, between government and industry. Between nations, between giants and those who aspire to be, between talent and opportunity, between aspiration and foundation. Between science and nature. Between intimacy and community. Today, Nicosia is a gateway into the future. A gateway to new world-class developments. A gateway to exceptional investment opportunities. Nicosia, your gateway to the future.
We will now continue with session 3, Vision for the Moon Village Present. This session will include a selection of presentations from the call for papers and a roundtable discussion, moderated by Antonino Salmeri.
We're live.
Hello everyone, and welcome to this panel discussion. My name is Antonino Salmeri, and I'm going to be your moderator for today's session within the NVA Annual Symposium on Vision for the Moon Village, the Present. Today, I have the great pleasure of being joined by a very distinguished lineup of panelists and speakers who come from our call for papers, but also from the various subjects of the space community coming together to discuss the visions for the Moon Village. So I'm very happy to have with us Ms. Alison Decker, Ms. Nellie Osford, Dr. Maxim Litvak, and Mr. Bob Lamboret. I will tell you more about all of them when I introduce them before their presentation. But before I do that, I'm just going to share with you some housekeeping rules so that you're aware of our event is going to work today. So we're going to have, first of all, a series of presentations from our panelists, and each of them will take 10 minutes to present a topic on which they've written a paper. Then there will be 5 minutes to ask any burning question you may have to a specific panelist. We will go one panelist after the other until we reach Bob, who also kindly agreed to be with us today on behalf of the Luxembourg Space Agency. He will also give some remarks on the perspective of the LSA for the development of lunar settlements. And then after that, we will start a panel discussion, which will essentially take the starting point, the conclusions developed in the paper presentation, but also any question that may come to us in the audience. So I would encourage all of you, however you are following us, to ask your questions. If you are with us live on Zoom, feel free to drop them in the Q&A section. I will be keeping an eye on them. If you're following on YouTube or any other media channel where this may be live streamed, please drop a comment, and I'm sure our technical moderators will make sure to forward the questions to us. And I very much invite all of you to engage, because this is a very exciting topic, and we want to hear all your perspectives. And you today have a great opportunity to engage with amazing panelists on this subject. So just take the opportunity and ask any question you may have about how we're going to build this fantastic moon village. So what it is that we're going to discuss indeed today, what is the moon village? As some of you may remember, this was an idea launched originally by the Director General of the European Space Agency in 2015. This idea of an environment, a shared environment where competition and cooperation can thrive from different countries and across different sectors. So the idea of the moon village is a shared space that all different countries and players, public or private, commercial or scientific, new or old, can come to and do their activities on the moon. So it's a place where we can integrate capabilities, where we can reinforce each other's efforts and commitment to space exploration on the moon in order to enable then a new era of more sustainable and also affordable access to space exploration. This, of course, is not something that happens overnight. That's why you have organizations like the Moon Village Association, of which I'm very proud to be part of, in order to promote the implementation of the vision of the Moon Village. And that's why this annual event organized by MBA is so important, because it gives an update, an overview of where do we stand in terms of the realization of the Moon Village. And of course, MBA is not alone in this effort. There are different other organizations that cooperate with MBA for the realization of this goal. I will just mention a few of them. One is that an organization that I do a lot of work with, which is the Space Generation Advisory Council, which provides the perspective of the young generation and future and present young professionals in space on these very topics. So with MBA, we have been working together on a number of topics, like the topic of lunar governance, for instance. And MBA itself started a very good and renowned initiative, which is the Global Expert Group on Sustainable Lunar Activities, JAXA, which is a multi-stakeholder platform bringing together, I think it's about 36 experts from all over the world, from different sectors, different disciplines, in order to discuss what would be the starting point for the development of principles, guidelines, and concrete, tangible deliverables for the regulation of lunar activities. But of course, discussions in policy are just a part of this. That's why today we have a panel that I'm very proud to say it's very diverse in terms of bringing together different perspectives. So we're gonna have Alison talking to us about the jurisdiction and enforcement issues. We're gonna have Nelly talking about the communication and infrastructure development for those purposes. And then we're gonna have Maxim providing an overview on the next lunar mission from Roscosmos. And then of course, Bob talking about the amazing work that the LSA is doing. So we really have all the different perspectives we need to develop the Moon Village. And I'm very excited to see how this panel will kick off. So having done this very brief, but I hope also comprehensive introduction, I would like to introduce our first panelist, Miss Alison Claire Decker. She always had a passion for law and space, which is why she joined ESA DASTRA, which is an organization that if you don't know, you should definitely get in touch to. It's focused on bringing human rights to the stars, and Alison is legal advisor for the ESA DASTRA project. You'll find Ms. Decker exactly at the intersection between space law and employment law. Is She's an experienced general counsel, litigator, board member, executive, and space attorney for many different organizations and different events. So we're very happy to have her today. And she's also a member of the advisory board for the Smoky Hawk Solitons, sorry if I pronounce this not correctly, which is an aerospace propulsion startup. And in 2021, and of course, I'm not surprised, she started her own law firm, Ellison Clare Law. So Ellison, it's great to have you today with us. You have an impressive bio, and you wrote an amazing paper on enforcement, on jurisdiction challenges for lunar activities. So we very much look forward to hear from you. Thank you.
Well, thank you. Thank you for that great introduction. I'm just going to go right in and share my screen for a little bit of my presentation. All right. So within the next 5 to 10 years, humankind is going to return to the moon. And this time, we aren't going to just turn around and come back home. We are going to start establishing long-term installations and facilities on the lunar surface. With this in mind, and with the rapid growth of private missions and space tourism, the question of how jurisdiction will be determined for private civil actions arising from incidents that occur in space is no longer some interesting thought experiment, but rather a pressing concern. Unfortunately, our current international space laws focus largely, if not exclusively, on states as actors, and they do not provide mechanisms for individuals or private entities to assert any rights without going through a state agent. Thus, there remains much uncertainty for both private companies and citizens who intend to build, work, and live off-world. And such uncertainty can hamper further commercial space exploration. Now, I want to give you a quick overview of the written piece I prepared for this symposium entitled The Waning Crescent of Jurisdiction on the Moon. So first off, let's talk about current international space law. Now, most people might start their lunar jurisdictional analysis by looking at the agreement governing the activities of states on the moon and other celestial bodies, aka the Moon Agreement. This agreement creates an international space commons on the moon by prohibiting states from establishing sovereignty or claiming ownership over the surface or subsurface of the moon. But it allows states to retain jurisdiction control over their personnel, space vehicles, equipment, facilities, stations, and installations on the moon. This control over installations and other facilities is extended to non-governmental entities, as states are required to ensure that non-governmental entities under their jurisdiction shall engage in activities on the moon only under the authority and continuing supervision of the appropriate state party. However, very few spacefaring nations are parties to the Moon Agreement. Now, another basis for lunar jurisdiction might be found in the Convention on the International Liability for Damage Caused by Space Objects, also known as the Liability Convention. Under this convention, jurisdiction is based on what country a space object, which would include a landed facility or even a portion of an installation on the moon, was originally launched from. However, one of the problems with the Liability Convention is that it would be very possible for different parts of an installation, like the different modules of the International Space Station, to be multi-jurisdictional or even governed by completely different jurisdictions based solely on the original launch sites of the different component parts. But what really makes the Liability Convention a poor choice for determining jurisdiction is that Article 7 creates a unique set of limitations for private citizens who are nationals of the launching state or nationals of other states who were invited to participate in the operation of that space object. Article 8 further limits potential claimants to states and not private entities. And Article 9 requires that states attempt to enforce any liability claims through diplomatic means or through the Secretary General of the United Nations. So if we don't have a clear-cut answer to lunar jurisdiction under either the Moon Agreement or the Liability Convention, can we cobble something together by expanding traditional terrestrial jurisdictional jurisprudence to the moon? The Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and Other Celestial Bodies, known as the Outer Space Treaty, states that states are responsible for national activities in outer space, including the moon and other celestial bodies, whether such activities are carried on by government agencies or by non-governmental entities, and requires both the authorization and supervision of non-governmental entities acting in outer space by an appropriate state. Thus, in essence, it allows for currently existing laws to be given extraterritorial force in space outside of the specific physical jurisdiction of the state. Now, if we combine this with the fairly well-accepted concept of the moon being an international commons and add in the Convention on the Registration of Objects Launched into Outer Space, aka the Registration Convention, which requires a launching state to register their space objects in a national registry, we end up with something that looks very similar to the maritime registration system that we currently have on Earth, which is enshrined in Articles 91 and 92 of the United Nations Convention on the Law of the Sea. Under this system, the owners of a seafaring vessel pick the country they want to register with and are then bound by that state's exclusive jurisdiction in international waters. Here we would be doing the same thing, but with space objects, including those located on another celestial body like the moon. However, it isn't entirely clear as to whether liability under the Liability Convention transfers with registration, nor has the system to date been used by private companies in the same way that they utilize traditional seafaring ship registries back on Earth. And perhaps more troubling, there does not appear to be any enforcement mechanism for failing to register a space object, as not all current space objects are registered, which could lead to the creation of pirate or lawless celestial facilities and installations. Now, one of the problems with simply exporting terrestrial jurisdictional concepts to space is that we aren't correcting the problems that already exist within these systems back on Earth. And there are many more opportunities for exploitation and abuse in space. The wholesale exportation of maritime law extraterrestrially could simply result in the expansion of the concept of flags of convenience to space. Thus, there could be, as there has been for traditional seafaring ships, a race to the bottom with private companies registering their space facilities, installations, and ships with states that have the most favorable laws for them, such as those allowing for more exploitation of labor and less enforcement of safety and pollution regulations. Not to mention that current terrestrially based legal systems do not consider the very different situations that can arise in space versus on Earth. And it can also create significant enforcement problems if the only way to seek enforcement is suing, perhaps in a foreign country, back on Earth, which may make it impossible for most individuals to seek redress for any violations of their rights or injuries that they sustain while in space. Another potential solution for this jurisdictional uncertainty in space is using detailed contracts to determine what laws apply, what additional rights might exist for space-specific issues if pre-existing laws do not set clear rules or merely set minimum guidelines that the parties want to expand upon, and the location where one can sue or attempt to enforce these rights. And there are numerous terrestrial examples of such contracts, from the infamous form and venue selection clauses for passengers on cruise ships to the detailed agreements negotiating pay and other rights and duties that were common on ancient pirate ships, to international contracts between various private entities that often include venue, forum, and arbitration clauses. Of course, the big concern with determining jurisdiction based primarily on contracts is that if the bargaining power between the parties is not equal, one party may be able to force upon the other unconscionable terms. And even with the best contracts, we still are left with the fact that if the only enforcement mechanisms are back on Earth, it may take years and a return to Earth for any justice to be had. In short, we are going to need to write new laws that address the issues that are specific to different space environments, including, but definitely not limited to, minimum environmental and atmospheric habitability requirements, guaranteed access to oxygen, food and water, protection from radiation, and new guidelines as to what constitutes a workday and work week. And given the lack of current enforcement mechanisms off-world, we are going to have to create new and different judicial systems in space, ones that will address the unique roles that will eventually develop in different space and environments, and which will also offer a way to enforce the applicable rights and duties of all space actors while they are in space and in an expedient and fair manner. But we aren't there yet. So we have to focus on bringing what certainty we can to lunar law right now. And the best way to do that is expanding current maritime law to space and using detailed contracts to create order out of potential legal chaos. That's sort of just a brief overview of what I wrote in my paper, and I'm very happy to be here today and talk about these issues.
Thank you so much, Alison. I think that was really nice and well done. Your paper was very interesting, and the presentation, I think, even more. So thanks so much for that. And also thank you for staying within the time. Very much appreciated. Anybody who has questions within the panelists, I have a couple in mind, but I want to give precedence to the panelists. If you have any question directed to Alison. I'll start with one in the meantime. I don't see I see no questions so far in the Zoom. So the idea of comparison with maritime law is very interesting, right? And one of the things you mentioned is that in maritime law, a single, a commercial operator can choose the flag under which they want to register their vessels. Now, in space, it's not exactly like that, because registration is only allowed for launching states. And it is not that you can pick any launching state in the world, because this capability is actually very limited, right? So how do you say this fundamental difference between the fact that in maritime law, you can go to any country and register your flag and your vessel there, whereas in space law, you're limited only to the states who are capable of launching your object?
So I think that is a really important distinction, because right now the access to space is completely controlled by spacefaring nations that have launch capabilities or can control launches. And yes, at this point, most space objects are registered to the states that they launch from. But there is precedent for states to transfer registration, basically taking a space object off of their registry list and then having it transferred to another state that adds it to the registry. It hasn't happened very often, but it has happened with some types of satellites that have been transferred between countries. So I think it is possible eventually, and it may become more common, for the launching state to be separated from the registration state. And especially as we begin to move assets around, or private companies, work with one state and then may work with another, or launch from one state but be based in another state, I think we're going to start seeing more of this registration that isn't solely tied to the launching, but is tied to where you want to establish your citizenship for your space object.
All right, I'd love to see actually to know more about these cases, because as far as I'm concerned, when this may have happened, it could have been in two ways, right? Either an internal transfer of ownership, so like that you do a sort of redistribution of jurisdiction, but without any effect at the international space law level, or if it has been moved from one country to another, and honestly, I'm not aware of this ever happened in the UN registry. It could only be from a launching state to another, right? Because Article 8 and the Registration Convention are very clear about it. So you need to qualify as a launching state in order to do this officially with the UN. Now, for sure, internally, maybe you can have, and there are arrangements to say, okay, I don't have any control of this because it has been sold to another company. So let's find a way to solve this. But it will be only internal, right? It will not be external. So one way to solve this could be interpreting in a bit more extensive way the concept of procuring the launch, right? So we could expand the range of states considered as launching states by including those states who may have a financial interest in the launch, either because the company is registered in their jurisdiction or whatever, right? So maybe by interpreting that in a more large way, we could have more states at the table. But the fact remains that with the UN system, so will not accept the registration if you cannot exhibit proof that you are a launching state, right? So that still, I think, remains.
Right, and in generally, when it has been transfers of a registration, it typically has been between different states that do have launching capabilities, and they have transferred satellites after they've already been launched for whatever reason. And there are only a couple examples of that, but they are recognized as transferring the registration. The question of liability transferring has not actually arisen yet. And I think that's more of the issue, because yes, you can transfer your registration, but if that doesn't transfer your liability, it doesn't really make any difference. The liability convention also does allow for joint launchings when there are more countries involved in sort of a mission together. And so I think that's also a possibility to bring that in, where it could physically, the launching state may not be the only state that is responsible for this jointly launched object. And I think we're also going to start seeing at least some of the private companies are now reaching a level where they are capable of creating their own launch systems and their own launch pads and that kind of infrastructure. They weren't there, 5-10 years ago. I do think some of them are very close to being able to do this on their own now. And at that point, I think you are going to see an expansion of states that do have launching capabilities, because they will be launching through or using the resources of a private company who's created a specific launching facility in their country. So I think there might be more expansion along that line as well. But yes, right now the systems are not set up very well for non-state actors to really to really sort of exist in space in a way. You can only do it with state approval.
Yeah, indeed. It's a very fascinating subject, and I have more questions, but we can come to that in our panel discussion, I'm sure. So thank you, Alison. This was already a great start. I'd like to move on just to stay within our schedule and go to Miss Nelly Offord Harley. So Nelly graduated in aerospace engineering and business from the Institut Supérieur d'Aéronautique et de l'Espace, the SUPAERO, which is a grande école in Toulouse, France. Nelly started her career in the automotive and aerospace sectors, and then she settled in space in the space sector, not yet in space, but I wish that for you if you like, of course. In 2012, where she joined Airbus Defense and Space, serving under different capacities for the company. In 2019, she then transferred to Surrey Satellite Technology to head the exploration business development. And since then, her main focus has been on the realization of the company's ambitions in lunar communication and navigation services, looking at how do we offer commercial lunar data relay service provision with the Lunar Pathfinder from 2024 onwards. So very fascinating and rather more technical, of course, and business focus. So it's really great to have you with us, Nelly. Without communication, we can't do any sort of lunar activity. So we'd love to hear more from you. Thank you.
Thank you very much. I gave you a lot of acronyms there to read. I appreciate it. That was a kind of a test you passed. Let me see if I can share the screen for my presentation.
Wonderful.
You can all see that. Okay, so after the question of jurisdiction around the moon, we're going to talk about something extremely different, nonetheless very useful as well, of communication around the moon. I just have a few charts to help with my talk. And as you could see, while I was being introduced, the lights came off in my building, and now I am just taking my watch out, which is completely automatic, to make sure that I'm going to keep on time. So we're talking here about a shared infrastructure to provide essential needs, so communicate, locate, interact, rescue. This is what we're talking about here, and this is why it has its place in the Moon Village Association Symposium. Who on Earth could live without connectivity, without communication, without location and navigation services? We can see that wherever we go today, we are putting on the GPS, even if we've gone there 500 times, at least what I do. I still use a GPS to go to work, and I've been going there every morning for the past 5 years. So what should the moon be any different? We're talking here about an infrastructure which is ultimately going to be a constellation of relay satellites in lunar orbit, capable of supporting any lunar mission. So here you need to think about an infrastructure that is commercially available for any mission, be it institutional, commercial mission, and anywhere, any type around the moon. The primary objective is to meet the primary needs of those missions, connect the missions back to Earth without the need for direct line of sight. So there are very obvious examples in which we know that a data relay satellite is needed. Far-side mission, for instance, that do not ever have direct line of sight to the Earth, need a data relay to be able to transfer their communication back. And mostly they're doing it through data relay satellite. It is also true for a large portion of polar mission, which have a very oblique direct line of sight to the Earth, and no line of sight at all if they happen to wander behind a mount or any any sort of geography that keeps that gets in between the Earth ground station and the lunar asset in question, and was thinking also about low-range missions. So to be able to communicate and receive navigation signal from Earth ground station directly, you need to have pretty powerful receivers and emitters. And here, having a local infrastructure once again allows missions that otherwise wouldn't be able to communicate. So that's a primary need of the mission. It also enables precision landing and location finding, again, primary needs of exploration missions. Finally, it allows exploration missions to save on costs, technical complexity. I talked about the receiver. Indeed, here we can spare the big, expensive, heavy and costly receiver to receive the communication signal or the navigation signal by outsourcing all this complexity into the local infrastructure that's going to handle all this on behalf of the lunar user. And we can talk also about more sophisticated needs, data streaming, teleoperating, real-time connectivity for astronauts. So when I talk about what I do to my 9-year-old son, I forget all about the primary needs, and I explain to him that he's going to be able to have a remote controlled rover on the moon. And that's really what we're talking about here. We're talking about FaceTiming between the astronauts and their families. And the second point, which is we can then start expanding communication and navigation onto all the other applications we could think about: health monitoring, safeguarding of human life on the moon and the environment, tracking of assets, and then maybe we could get back to the jurisdiction and law aspects that we were talking about. How do you know whether an asset is within your territory or whether it's impeding on what you have a license for? Well, you will need very precise navigation capability to be able to do so. This will be done in 2 major steps, built on years of work between SSTL and ESA. So Lunar Pathfinder, which is a single spacecraft which will be in orbit around the moon by the end of 2024 and operating for 8 years, and I'll get back to that in a second. And then I'll move on to the ESA Moonlight Initiative, which is a constellation that is going to provide all the services I've described before. So here is the identity card of Lunar Pathfinder, which is a first step of lunar communication and navigation services. So I've said it is a single data relay spacecraft. So it is only capable of providing communication services, because for navigation services, you need more than one data relay satellite. But it will also have hosted payloads that will be able to demonstrate the navigation capability. So an ESA GNSS receiver, a NASA retroreflector, and also an add-on, which is an ESA radiation monitor to be able to provide some vital information about the radiation environment on that orbit. It is developed by SSTL in partnership with the European Space Agency and in collaboration with NASA. It will be operational by the end of 2024 onwards for an operational lifetime of 8 years. It has a mass of about 330 kilograms. So if you can imagine a washing machine, like unfortunately it shows in this drawing, it's about the right size for Lunar Pathfinder. And then a few technical property. It communicates with the lunar asset in UHF and S-band, in X-band for the Earth link. And we've put here some maximum user data rates, up to 5 megabits per second in X-band and up to 2 megabits per second in S-band, depending on the location and user performance. So you will be able to have a play with all of this by logging into our Lunar Pathfinder mission builder. You can see the picture on the right-hand side. It's all on our website. You can connect on the website and enter a few parameters of your mission, and then you can see the coverage that you can hope to have have using the service, and also the data rates. And it will give you an idea. And if you want to know more, you'll be able to contact us, and we'll be more than happy to simulate the service for your mission. The second step is the ESA Moonlight constellation. So we are right now leading one of the phase AB1 study for the European Space Agency for a very ambitious initiative called Moonlight. which is about realizing what I've put in the first page. It is a communication and navigation service provision that is relying on a full end-to-end infrastructure. So here we're not talking just about one data relay satellite, talking about dialoguing with lunar asset and ground station. We're talking about a full ecosystem, a lunar constellation, ground segment on Earth, lunar surface segment, user equipment. We're talking about high data rate, broader range of communication services, full navigation services, full coverage of the moon, large capacity, and again, end-to-end infrastructure, including lunar surface segment to augment the proximity infrastructure. It will be fully operable with other lunar infrastructure and compatible with LunarNet. I just want to get back to that point because it's not just a technical consideration. The idea of Moonlight is that it is part of the overall lunar ecosystem, the Moon Village, for instance. And it is very important for the European Space Agency and for us that this infrastructure completely blends and interoperates with everything that is available and operational on the Earth. We are looking at sustainability and usability here. And this is why interoperability, whether it's with LunarNet is the obvious one, but whether it's with LunarNet or other ambitions that are for sustainable return to the moon, we need to make sure that we are working together. It is a duty that we have. It is done in it's again like Lunar Pathfinder, a European commercial partnership open to further collaborations internationally. And that's it for my presentation. I am happy to take questions if you have time. I have no idea how I've done on time. So Anthony, you'll tell me.
Thank you very much, Nelly. This was extremely interesting, I have to say, and I would say also extremely important in terms of the concrete capabilities we need for the development, of the Moon Village, in any actual infrastructure that we want to have on the moon. I think you did excellent on time. You're also very well within the 10 minutes, so thank you so much for that. As usual, I have some questions. There is also one question in the Q&A function. I'll start with that. Which is a very technical one, it says, what is the maximum data rate anticipated for Moonlight? From Dallas. Yeah.
For Moonlight, it's much more than Lunar Pathfinder. So for Moonlight, we're looking at very high level of data rate in excess of 50 megabits per second. But I'm saying in excess of because I can't give you the answer today. It's still in study. And we are very early yet in the study, so we are down selecting some initial concepts that we will be working on. So it's a little bit premature, but I can tell you that we're looking at much higher data rate than for Lunar Pathfinder.
Thank you very much. Thanks, Dallas, for the interesting question. Again, any question from the panelists at this moment? Alison? Yes.
Because right now for astronauts, communications are so closely monitored and they don't really have the ability to contact anyone that they want to and vice versa. It all has to sort of go through whatever launching state is or state is controlling the mission. Are you envisioning this as also a way to have private communications where people would, the way we could access our own cell phones and personal phones and emails now, or is this still going to be more of like a closed system?
It's a very good question, and we haven't really thought about it. We've been thinking more about what are the technical capabilities that we need to ensure such a link. Now, we are very open in the way that the service needs to be operated, and we are very open to answering the needs. But I have to say, I haven't really thought about the private or commercial element of it. I think that initially the service will be expensive enough that it will be controlled by a small number of companies who actually are sending their own astronauts to the moon. Now, whenever and in a number of years, the moon becomes accessible to private users who could be interested in in commissioning their own link, that is a question that we'll have to look at in terms of how do we make it secure and how do we control it in the end.
Right. We have a lot of questions actually, so we're going to keep them for later. Certainly your presentation raised a lot of interest, but we have to stay within our schedule for the moment. So I will pass now to the next speaker, and then we will come back to all the questions remaining and many more, of course, into our panel discussion. So our next speaker is Dr. Maxim Litvak, who is a professor of the Russian Academy of Science since 2016 and the head of Laboratory Neutron and Gamma Ray Spectroscopy in Space Research Institute since 2014. Dr. Litvak is author of more than 150 science publications in peer-reviewed journals. That's very impressive. In 2005, he was nominated to the degree of Doctor of Science at the Moscow State University, and nowadays he's participating in different projects closely related with the development, the research, and the testing of new science instruments for numerous Russian, but also foreign space missions, like, of course, the Luna 25 missions that he's going to talk about us, I think, today. So, Dr. Litvak, Maxim, it's really great to have you with us. Thank you so much for joining, and we look forward to hear from you.
Good afternoon to everybody. I try to share my presentation right now.
Please try. It's coming up.
Okay.
Right?
Okay.
Works great.
Okay. Thank you very much for introduction, and I would like to start my presentation about a couple of words about the Russian lunar program. So it is being discussed and developing for a long period of time. Our Russian Federal Space Agency trying to settle the milestones, to find the schedule, to find the best compromise because of the available funding and science and the technological goals of the program. Also try to understand how to participate in the international cooperation. And now it is agreed that the first stage of the program will be the so-called robotic missions. We plan to send to the moon several polar landers and the orbiters. First of all, to study the lunar subsurface, to study the lunar environment, especially around the polar regions, just to understand and to select the best site for the future human landing and potentially for the creation of the lunar base. So the Luna 25 is our first mission in this program. It is very critical for us because it is the first. And our last mission was dated by at least 50 years ago in 1976. So now we need to develop the new technologies to test the return to the moon, to test the soft landing, to test some key technologies, and to test that the robotic mission could operate for a long period of time on the moon's surface. So on my first slide, I try to summarize the goal for the Luna 25 mission. And of course, the first primary goal is just to test the subsurface in the polar area and to search for the volatiles. And first of all, just to understand the water ice distribution in the polar regolith, because it could be important not only for science issues, but also for the future human mission as a very necessary resource for the presence of cosmonauts on the lunar surface. It is important that for the Luna 25 we have selected the so-called near polar location. The latitude of the landing site is about 70 degrees on the southern hemisphere. It's not far away from the Boguslavsky crater. And we expect that in this location we may face with the polar type of the regolith, and we would like to study this polar regolith to understand the elemental and the isotopic composition, and also to understand the presence of the water ice in this area. That is why on this screen I just present the orbital map of the potential presence of the water in the lunar surface. And we selected this landing site as a location at which we may find the presence of the subsurface water ice. To implement this goal, we especially prepared the payload for the Lunar 25, and I would say the center of this payload is the robotic arm, because we would like to conduct the so-called contact operation on the moon surface. It means that using the robotic arm, we would like to excavate the subsurface to remove the top dry layer and just to excavate to the potentially water ice rich layers, which means some tens of the centimeters. And we also need to take the sample of the soil and to deliver the sample of the soil to the special instrumentation. In our case, it is a laser ionization mass spectrometer, just to study the elemental and isotopic composition of this element of the soil. It is important because this technology will be implemented in the future mission, because in the future mission we plan the more complicated system, including the drilling system, which will excavate to more deeper layers and will be landed in more polar regions. So on this slide, I just to present the combination of the two figures. So the figures on the left present just the three-dimensional model of the Lunar 25, showing the instrument suite which is responsible for the contact operations. So if we are going from the bottom to the top, the first one is a robotic arm, which is necessary for excavation and the sample delivery. Then this is a so-called LIS TVRPM instrumentation. It is infrared in the stereo cameras which are installed on the robotic arm, and the robotic arm uses this instrumentation to study the surface around the spacecraft. The next is the laser ionization mass spectrometer LASMA, which will process the samples which will be delivered by the robotic arm. And on the top, you will see the stereo camera which installed on the spacecraft, and we use the stereo camera to navigate the robotic arm. And on the right figure, you may see the real photo from our institute. Then we use a mock-up of the spacecraft just to test the qualification model of the robotic arm. So in our study, we understood that it is not. It is important not only to test the standard the space qualification test like we do usually for the space instrumentation, but we also need to understand how we may validate this contact operations with the robotic arm. That is why we specially developed the relative huge thermal vacuum chamber in our institute. In this chamber, we put inside the technological model of the robotic arm. In this chamber, we could provide the pressure like in the moon condition. We could provide the ambient temperatures like we expect on the moon, like we expect in the space. And we also will be able to put in the chamber the analog of the lunar regolith. So the idea was just to test the robotic arm operation in this chamber and to understand how it could be excavate the analog of the lunar regolith, just to take the samples and to deliver the samples. It was important that taken into account that we expect that the subsurface at the landing site could be enriched with the water ice, we take the dry analog of the lunar regolith and mixed it with the different concentration of the water. We know that from our orbital observation, the concentration of the water in the landing site of the Lunar 25 could be as large as about the 1%. And this 1% of the water ice could be located at some depth. So we created several analog of the lunar regolith different with a different concentration of the water, and then we put in the chamber, pump the pressure to the space conditioning to freeze the analog of the lunar regolith to the temperatures which we expect at the landing site, which is about something like -100 Celsius. So on this slide, you just observe the result of our test. So I just provide here the real photo from the chamber. On the top left figure, you may see the excavation process. Then the robotic arm excavates the frozen analog of the lunar regolith, mixed with the different concentration of water ice. And in our case, the top value for the water ice was 1.5% by mass fraction. Also, on the top row of the figures on the photos, you may see the process of the sample delivery. We just put the special sample caps inside the thermal vacuum chamber, and the robotic arm take the sample and to deliver it to the caps, and then we open after the test the thermal vacuum chamber. We will analyze the sample which was collected by this way. Finally, on the bottom row, I also just presented in the, how to say, more huge scale the photos, how the robotic arm excavate the analog of the lunar regolith and how it is take the samples. You see that here especially I provide the photos for the most water-rich analog of the lunar regolith which we used in our test. So you will see that a lot of such agglomerates of the soil which was formed just because the particles, the soil particles are just stitched to each other by the water ice, and as a result, the strength of the regolith was increased significantly, and it provides a significant difficulty for the excavation process. And here you may see that it was not so easy process. But finally, we found that expected presence of the water ice at the landing site could be excavated by the robotic arm, and that the samples could be taken successfully. We tested that it takes the sample, it takes the expected amount of the sample which is needed for the analysis on board of the Luna 25. So it was our current ground success for the ground test of the robotic arm in the Luna 25, especially taken into account that currently we are in the finish line and we are passing the assembling, testing, and the launch operation. We have about half a year before the launch. And this technology which we tested now will be implemented for the future mission, just to test technologies in the lunar-like condition. So here I would like to stop and wait for your questions. Thank you.
Thank you so very much. This was really interesting. And I think it's one of the most important missions we can see over the next 5 years due to the need we have for studies on the lunar regolith. Thanks also to you for staying within the time. That puts us on a very nice schedule. So questions for Maxime from any of the panelists? Okay. Yeah, Nelly, you want to do? Please go ahead.
Sorry, I was desperately looking for the unmute button. Yes, Maxime, I had a question about how you recreate the environment for the moon. Is it are you relying on data being brought back? And of course, I'm linking it back to the retrieval of data for you to be able to create the environment in the test chamber, or is it based on the previous missions that you've had and the regoliths that were brought back last time?
Okay, thank you very much for the question. First of all, of course, we did not reproduce the one-to-one, the lunar-like environment, because it is complex. We tried to focus on the issues which are very necessary for our test. And for our test, it was necessary to recreate the pressure, which is the pressure in the space, and also necessary to recreate the lunar regolith, and we use the analog of the lunar regolith. And also it is necessary to reproduce the temperatures, the so-called cryogenic temperatures. So this is the three basic factors which we are using in our ground test. And I would say that pressure it is known. The temperature we take from the observational orbital observation available for us. For example, if you take LRO mission and the instrument Diviner on board NASA LRO mission, and the Diviner instrument, which is measuring the temperature map of the moon, we could take the temperature of the landing site. And of course, we are using our assumption how much ice we could observe in this particular place, and we're trying to model, not of course, we do not know the exit value, but we could produce some range. So we tried to reproduce the range of the potential quantity of the water ice during our test, and found that our robotic arm design is capable to excavate and to take the samples, because it's quite important just to understand before the mission that everything is okay. So that was our approach. But for next test, the situation could be more complicated. So it is possible to model the dust environment to understand some potentially issue with the sun illuminations. But for that, we're also planning to look in the future to design the more huge thermal vacuum chamber with the more equipment to just model this environmental, I would say, in more detailed way, but it is just the future.
Wonderful. Thanks you, Maxim, for the comprehensive answer. I'm sure I have so many more to ask, but I'll go to Bob, and so we can then finally begin our panel discussion with the questions that I didn't forget from before, and of course, many more that will come. Thanks everybody for being very engaging. So last but not least, of course, Bob Lamboret is currently policy officer at the Luxembourg Space Agency, where he's following space science and exploration matters and supports the development of local talents through educational programs and research projects. Bob has a particular interest in space exploration and, of course, in situ resources utilization, any topic related to that, and he's actively involved in the development of the Space Resources.lu initiative. Indeed, I would say that at the moment, there's no better place than Luxembourg in the world to be interested and work with ISRU. And in fact, Bob supports also the recently established European Space Resources Innovation Center, ESRIC, as strategic advisor. And he's probably one of the most knowledgeable people on this subject. So Bob, thank you so much for joining us. I would love to hear your thoughts on this topic, on the panel, on the visions for the Moon Village, and then we'll begin our discussion right after. Thank you.
Okay, thank you, Antonino, and thank you for inviting me to this very interesting panel and giving me the opportunity to share with you what we do in Luxembourg and how we support this new age of exploration and different exploration. Give me one moment. I just share my presentation.
It's coming up.
So there we go.
Yes, we see it. Perfect. Thank you so much.
So my name is, as Antonino mentioned, my name is Bob Lamboret. I'm a policy officer at the Luxembourg Space Agency. And I want to share with you a few ideas and what we do in Luxembourg to support space exploration and more commercially driven. So to start my presentation, I would like to remind everybody that Luxembourg launched in 2016 and the Space Resource.lu initiative that says that Luxembourg aims to contribute to the peaceful exploration and sustainable utilization of space resource for the benefit of humankind. So this is a very broad statement. I think it's also important to know that this is not a mission in itself. It's rather a very comprehensive approach to what we believe is needed to create a more commercially driven and more sustainable space exploration. So why did we do this? We believe that space resource, they are available. We know more or less where they are, what we can find where, especially, for example, the ice mentioned earlier. And we believe that the space resource are the building pillars for future space economy. They will allow different new space exploration missions. So if you look at all the different plans of the big space agencies and their lunar bases, they all at some point consider using space resources lunar resource to allow them to stay on the lunar surface on the long term. And then we believe that space resource is a very, very important element when it comes to commercial value. If we want to build up a more sustainable lunar presence, we need to have a good reasons to go there. If we want to involve more commercial private partners, we need to give them the opportunity to pursue their commercial goals. And so space resource in this regard plays an important role because it will create value in space by exploiting those resources. This slide I want to share just briefly the summary of a study we did in 2018 on space resource. When we speak about space resource, what is it? What will be the next development phases? Where we can find what? And and most importantly, what are we using the space resource for? So in this slide shows an overview of that summary, and we can clearly see that the moon and water will be the next step. That's on the moon we will learn how to use space resources, and then later on, I think we move to. We believe we move to using the regolith, the metals, the oxygen captured in the regolith, and then afterwards move on to different destinations. Also, on the application side, I think the first very important application that will enable a lot of other applications will be the production of propellant for spaceships, for rockets, the supporting life, the astronauts producing oxygen and water on the moon, and then also building equipment and infrastructure. So how do we address this in Luxembourg? So we came up with the Space Resource.eu initiative, which basically has 5 pillars. One, a very important first one is on political support. Space resource is a very, very complex topic, and you need to explain a lot to what it is. You need to get support at many different levels, how to use the space resource and promote international cooperation. Then I think we already learned today the legal framework is a very important pillar. It's very complex. I think there's no clear, easy answer today. It will take many years to get to an international framework. Luxembourg is very much engaging in all these different discussions at many different levels. We believe that it's important that we all agree how to use space resources and what are the limits and who can do what. And also, most importantly, is also to allow commercial operators, private companies, to get active and to somehow create a legal framework where they know what they are allowed to do. Then we support research and education. We support innovation in industry, and we also try to innovate on different funding instruments, where we recently created a venture capital fund together in a private-public partnership. Maybe for the sake of time, I can skip this slide and just say a few words, last words on the ASRIC, the European Space Resource Innovation Center. So this is a national innovation center in the field of space resources we recently established in Luxembourg. It was done in close collaboration with the European Space Agency. And in that center, we mainly try to address technical, business, and economic aspects related to the use of space resource. So in that center, the center has not the mandate or the ambition to now look into the legal side, which is a very, very complex topic. I think we have other people in Luxembourg very much aware, very well aware of that. And so the center itself is built on 4 different pillars. It will have a research. It will conduct research project with its own research team. We'll have a state-of-the-art research infrastructure that we'll be procuring together with the European Space Agency, and for the production of metals and oxygen on the lunar surface. And also we'll also have a large dirty thermal vacuum chamber similar to the one that was presented by Maxime. We also have a startup support program, as we believe it's important in order to become a more sustainable environment. We need to allow commercial opportunities. So we support startups to develop technologies and services around space resources. And then we have two other more side activities, if you want to say so, on community, where we organize the Space Resource Week in Luxembourg. And on the knowledge side, we'll have a web portal where we share all the knowledge that's been generated in the center and also around the world in the field of space resources. So that's all. Thank you for listening. That's all from my side. I'm happy to answer any question.
Thanks so much, Bob. That was fascinating. It's always very enlightening to hear the perspective of the LSA, and now further enriched by ESRIC. There is so much that needs to be done at the international level, and having a player like the LSA playing this important role is, I would say, fundamental. Any questions from the panelists for Bob? Specifically, before we begin our discussion, but I want to give him fair treatment, and so everybody got a specific question, and I think it's only fair that we do the same. I have one, Bob, which is usually that people ask me, so I'm very happy to forward it to you now, which is, Luxembourg, as you said, is very much involved into the international discussions about developing sort of common understandings on how do we govern space resources. What is, in your view, the most difficult area that we are agreeing upon? Like, what is the most challenging thing that we need to sort out that can unblock then the rest of the discussion?
Yeah, you're referring to the discussions on the legal framework.
Let's say, yeah, legally or policy, even not necessarily, right? A legal question, but also in policy in terms of how do we do licensing, for instance, of these activities, right? How big can be a mining site? Any sort of question that we need to unblock from the, say, legal and policy side combined, something that is not technical anyways, right?
Maybe to start, I'm not the expert on legal matters, so on the legal framework we have different colleagues that are much more knowledgeable in that field. I think overall it's a very, very difficult or complex discussion. We need to find the right forums or bodies to regulate these. I think by creating the working group on space resource at UN level, that helps a lot to progress, to understand where to regulate this. I think also how to enforce this is a very, very exciting topic, very important. This will take many more years to clarify. I think we do not expect to have a clear way forward, find a clear way forward in the next years. Nevertheless, I think it's important that we all together understand what we want to regulate, how we want to regulate it, and to have a fair environment afterwards. And maybe copying what we know from Earth is not, maybe we should also use the opportunity to create something that might be more appropriate than just recopying something what we already know here on Earth.
Right, that's very well said, and I think it's a direct point for Alison, right? Should we do something new, or should we replicate what we have? Right, doing something new, of course, I mean, space would require something new, but it also takes a lot of time, right? As you said, Bob. And this also fits a question from Mark, like, what do we do for the implementation of the rules, international law and in international cases? So, Alison, maybe we could touch upon this once more, right? How do we find a balance between the laws that we have right now, which have some role, and the laws that we need to develop in the future?
I think that's a good question. And I also saw someone pop in the chat a question about, why is this even an issue right now? Because we have international space laws. The problem with a lot of the international space laws we have is that they, first of all, don't really recognize private companies or private individuals in space. And I think we've seen now that at least in America, a lot of our new space developments are by private companies. And, let's say, for example, SpaceX launches something into space. For whatever reason, it's damaged or destroyed by another launched object, and everyone on board is injured or something along those lines. At that point, there's nothing actually SpaceX or the individuals who are injured can do at this point. All they can do is go to their government and hope that the United States will diplomatically resolve this with whatever country launched it. And that's not really a workable system compared to how we deal with these kind of issues back on Earth, where if there is an injury, there's a loss, there's damage, there's theft, whatever it is, you have a way to go to your civil courts and resolve these matters. And when you're putting so much investment into these types of these things that cost, like satellites, space stations, installations, they cost millions and millions of dollars to make. Companies want some security that if there is a loss, if there is a damage, if somebody just goes up to the moon and takes it or lands on top of it, they're going to have some sort of recourse. And the same when we start sending private civilians into space, they want to know that they're going to be safe, that they are going to have oxygen and food and water and all these things that we sort of take for granted, but you can't take for granted in space. So that's sort of why this is important. And unfortunately, our international space laws don't really look at these individual sort of situations or these private companies. They very much focus on states controlling space as part of a governmental procedure. And we're seeing that not the same way it was back in the 1960s and 1970s. We're really seeing a commercial explosion in space development. So, and as Bob pointed out, private companies really also need to know what they are able to do. Like, what are the minimum safety guidelines you have to build to? How much security do you need to have? Or what kind of infrastructure? What do you need to supply for individuals who you are sending to space? There are no rules on this right now, and the international space laws do not get into those nitty-gritty things. We've also seen that it is very hard to get agreement on new international conventions and agreements. And we've seen this not only in space, but across the board. It is very hard to reach agreements on things. And many states are not signing on to new agreements or are able to back out of them, which sort of makes them useless. So I think the concern is that we can propose some of these ideas to have sort of international guidelines and rules, but there isn't necessarily going to be everyone who's going to sign on to it. Like, once again, like Russia, China, and America haven't signed on to the Moon Agreement, which sort of makes that not very useful because those are the big three spacefaring nations and they're not signing on to it. And then you see the Artemis Accords, which is not legally enforceable, but also just doesn't really include a lot of countries outside of America and their close allies. So once again, that's not really an international agreement that has buy-in from the international community. So I think that's sort of the problem I see with the law, that we need to figure out something to do before we can reach all agreement because we're not able to reach it.
Right, absolutely. And I'd like to thank Mark Sandel for the question. He's a professor at Lockheed University, a great friend and colleague, and he's the co-chair of the Coordination and Cooperation Committee within the MBA. So Mark, thanks for joining us. And I think what I completely agree with your answer, Alison. And I think what Mark wanted to point out is that, of course, we know who is going to exercise jurisdiction and who is going to have, at least some responsibility and liability for that, because you can easily point a state. The question is this very much suitable for private entities, and how do we bring them more in? And it's a very difficult question. It's an ongoing process that I think we need to work on. I promise I'm not going to make this a legal discussion. So I want to go back to, as much as I'd love to, but I'm mindful that this is a multidisciplinary panel. So, and we have many questions from Nelly. I see that you wanted to answer one already live, which is from Engel, right? So maybe you want to go ahead with that.
Yeah, I'm happy to answer that question. I didn't specifically point it out. I was playing with a Q&A and I pretty much whatever, but I'm very happy to answer it anyway. 4 satellites enough for PNT coverage, not for the R, sorry.
No problem. So the question is, are 4 satellites enough for PNT coverage, or will it be possible to add more satellites?
Yes, so the answer is 4 satellites enough for full PNT coverage of the whole moon, no. But as I mentioned before, we have an incremental implementation. So we're starting with 1, and then we'll start with a first deployment of a sub-element of the constellation, and it may be 4 or more satellites for PNT. We don't know exactly yet, but in that area. And then we will be enhancing the constellation further to provide coverage of other areas of the moon. But we'll start focusing on the South Pole region. Presumably, it's not completely decided yet, but there's strong indication that the South Pole is a desirable location for the medium to short to medium term missions. So we'll start there. So not just 4, but enhancement within time and demand.
Right, and there was a related question to that, which is about what's going to be the estimated cost for the development of the infrastructure. I don't know if this is confidential, so I guess, if you can share it or not, but if you want to answer anything like that.
There are many reasons why I can't answer it, because it's confidential, B, because I don't know. So let's say that it's confidential, so I can't answer, but the reality is that it's a very complex question that we are working through right now. And a little tiny bit early for me to be able to answer that question.
Yeah, very much understand. I have a question now, which is again coming from the Q&A. This comes from 2 people actually answering a very similar question. So one is Ryan, Ken, and the other one was let me just find it in the chat. Mauricio del Rio. So both of you, thank you very much. The question is about how do we minimize space debris creation on the moon, especially considering that there is no atmosphere to burn the satellites on re-entry, and that applies also, of course, to even more to the infrastructure we have on the ground. So who would like to take over this very interesting question?
I can start, and then I'll let Maxime go for the surface elements. So it's a very good question, and it's a question that we're asking because obviously we're talking about sustainable exploration of the moon, and by installing communication and navigation services, we're actually putting together the way of tracking every single piece of infrastructure on the moon and ensuring that it is abiding by the adequate regulation and disposition for the end of life. Now, for Lunar Pathfinder, what we've discussed with the space agencies, and namely ESA and NASA, is that we are making sure that we will follow the guidelines for end-of-life disposal and regulations in place at the time that we need to, at the end of the 8 years for Lunar Pathfinder, and much more for the constellation. And that's not for a company that is a small satellite manufacturer to answer, but we are very sensitive to it. We are very sensitive to sustainability. Indeed, we are active in active debris removal projects on the other side of the wall, and we're paying attention to the regulation in place and make sure that we're abiding by it.
Thank you. I think it's very important that we all develop and follow the rules that are already there, but we even develop more rules, which I think will be tailored for the lunar environment, right? There is also the question about whether certain objects constitute heritage, and so we want to leave them as they are because they represent, certain achievements that we want to preserve. Maxime, would you like to add anything on the surface aspect of debris or waste actually generation on the moon?
Actually, I would say only that right now I would say the following, that the lunar exploration started in the end of 60s, then the first astronaut stepped on the moon's surface. But since it is how many, 50 years, we still do not know much about the all important condition for the presence of the astronaut on the non-Earth surface. So there are many aspects which we need to somehow to understand how to recreate the conditions on the moon, on the Earth. And I would say that currently we are making only the kind of the first steps in this direction. And first of all, we need to I think we need to first need to continue the study of the moon, especially the polar regions of the moon, because making back to our previous discussion that we need to use the lunar resources, because if you would like to be on the moon for a long period of time, it is necessary to use the local resources. It's not possible. There is no so much money just to deliver everything to the moon. So we need to use the local resources, and now we understand that the local resources are available, mostly available on the polar regions of the moon. And we do not have any information about this location other than orbital missions. And now we need to go there to the surface just to study all situation in situ. That is why I would say, first of all, we need to send polar robotic missions to the moon, which will operate for a long period of time and provide a lot of data, which may significantly influence on our understanding how we need to plan delivery of the astronaut to the moon, and especially how we plan a long presence on the moon, like now we have the long presence on the International Space Station. So that is why I would say that we are only at the beginning of this road.
Definitely. Bob, you wanted to add anything?
Yeah, I would like to add one idea on debris, on, let's say, surface debris. So I think also from a resource perspective, one idea is we are currently looking into is to recycle the resource, let's say the lander in itself. As I think in the beginning, every kilo costs a lot of money, and also it seems to be very interesting to know how to recycle elements of a lunar lander and use it in a different way. You can call it circular economy, you can call it recycling, but overall have a very efficient way of using resources that are available on the lunar surface. And any lander, any metal that is there is, of course, a very important, interesting resource. And I think you can exclude all the heritage, all the old landers.
Yeah, we gotta
make a technical idea.
Probably one comment from my personal comment about the resources. My current feeling that if we are speaking about the commercial activity, the mining of the resources on the moon surface and then delivery of some resources to the Earth is not profitable right now. So my understanding that commercial services will be required, then we create the lunar bases on the moon surface. And I think it is a limited number of the countries are able to do that. And they may involve some commercial structures to help to create technologies which are necessary for the getting resources to support these lunar bases. And I also think that if the first lunar base will be created on the moon surface, it will be like the chain reaction. The many countries would like to have its own lunar base. And for example, if US, China, and Russia are able, and I would say the Europe countries will be able to create own lunar bases, I would say with some international participated, by basically this country have all necessary technologies for that. But if we are speaking about other countries which would like to have their presence on the moon surface, they need to go to these countries and to ask for help for technologies. So I think the significant commercial issues will be then the first lunar bases will be created, and the other country would like to get their own lunar bases, and they go to this United States, Russia, China, or the associated their commercial partners, just to help to create own lunar bases. And in this case, it will be just the commercial service, not between the moon and Earth. It will be commercial service across the moon surface. That's my feeling right now.
Definitely, and I think this is actually what will probably help the lunar sector to actually kick off, right? Because we need to have a local market for resources, for services. If we don't have that, it's going to be much difficult to ensure that it becomes economically viable. And I think, Bob, you're greatly positioned to tackle this question because, of course, Luxembourg doesn't have their own capability to build anything on the moon, but that's why, you play such an important role in the international arena, right?
Mm. I think a very, very important question if we want to have a long-term presence on the moon, on the lunar surface, and also let's say a more sustainable economy, lunar economy is the inclusion of private parties. I think we need in the next 10 years, we need to find the transition from purely public mission to private missions. And if we say private missions, of course, there must be commercial goals. I think a private company will never invest in any lunar surface activity if there's no money to be made. With that regard, maybe it all starts with a public scientific research station on the lunar base. But if we want to grow it to a more diverse place, I think we need space resource play an important role. Of course, the first use case is not to bring back space resource to Earth. That's, I think, is very, very well understood by the community. It's more to create space value in space on the lunar surface. Is about enabling long-term presence on the lunar surface. I think in the beginning it will be a lot about allowing astronauts to survive in a cheaper, maybe if you want to say so, on the long term on the lunar surface. But then I think we need to get the transition to a very diverse economic environment where you create a value in space, not necessarily on the lunar surface, but maybe somewhere between the moon and Earth, and use the resources that are available on the lunar surface for a useful application. I think this is really, really important, and that's also having commercial services available like the Lunar Pathfinder, the Moonlight project. That's really the way forward. We need to get away from standalone single public missions to a very broad, diverse environment with many private entities. And that's also where then on the other side, the legal framework plays an important role. So it all comes together. I think all these aspects are important. And yeah.
I just wanted to say, I think that's a really good point, that the moon is sort of still a test case sort of scenario for further exploration in space. Like if we can make a sustainable long-term settlement on the moon or installation or facility, we'll have an opportunity to be able to do that somewhere else. And so using that is still sort of the safe testing area to figure out how we develop these commercial systems, how we develop legal governance, making sure that we have the technology to be able to survive. The only place we can really test that for us is really on the moon before we try to go someplace like Mars or someplace else. You have to start there because it's the closest to most economically feasible. And if things go wrong, there's a way to get back, which we do not have as really an option at the farther we go out.
Definitely. And I think as part of all this, one critical concept is the idea of interoperability. So I'd like to go back to Nelly, and I was really surprised and pleased to see that your constellation you're planning will be fully interoperable. And my question would be like, how are you working on it, right? Because the interoperability means that you're able to understand what other standards will be used by others, what's going to be the frequencies and stuff like that, which is, I don't know how it's going to work in the lunar development side. Do you have a process for that, or how your constellation will actually be interoperable for everybody?
Yeah, so so today we're fairly lucky that the number of players with lunar missions, in the next few years is still manageable. That everyone who wants to have a voice in that community can express it. Now, what we're working on as a start with and it's mainly driven by the European Space Agency and NASA, is working out how to ensure the first level of compatibility between LunarNet and Moonlight. LunarNet has this aim, actually. LunarNet is a framework rather than a program. If you want to think about it as an ecosystem framework in which every mission can slot, this is a right way for us to think about what LunarNet is. Now, going a step beyond that, there are lots of groups that are working together. I'm thinking of the CCSDS group, for instance, who's working on standard and regulation for communication frequencies and protocols and ways. Each time I talk, the light comes out. Sorry.
Don't worry about it. I get you. We have the same systems in some meeting rooms here in Luxembourg. It's very frustrating.
I'm going to just ask someone to come in every 5 minutes. Yes, so there are some groups that are specifically thinking about that and that we are linking to within our project. And then the third way of ensuring it is by user engagement. And because we are building something from nothing, and for missions that are not yet on the moon, user engagement is extremely important for us, and the earlier, the better for us. So we've been reaching out and reached out to. It's by no way only a one-way conversation by future users and potential users from institutions, university, private companies who want to know how they can ensure their own compatibility with what we're doing. And we are also trying to ensure our own compatibility with them. And that's something that we need to develop. And I think that the Moon Village Association, for instance, as part of what, as an example of the many groups that are starting to gather around the Moon Village, is there to ensure that it has a responsibility in making sure that we are properly aligned and that we are able to behave as if we were building the Internet of the Moon.
Totally. I see Alison unmuted. I just have a follow-up point on this, which I've been meaning to ask during the presentation as well, which is about the infrastructure you want to develop on the moon, right? And you mentioned both on the near side and the far side. Now, my question is about interference, because as you probably are aware, there is a clause in the radio regulation of the International Telecommunication Union, Article 22.22, which defines a shielded area on the moon where any interference with radio astronomy is forbidden in certain frequencies. So my question is, like, have you, of course, I guess you have taken into account that. How do you plan to avoid that interference with the radio astronomy that will take place on the far side, but in general with other endeavors that may come up in lunar orbit?
Question for me. Yes.
I guess yes. You're the one.
I thought so, but I missed the name.
Well, anybody can intervene, of course, but I wanted to first of all ask your perspective, because you're doing a constellation and you're building infrastructure there, so I'm sure you consider that.
Yes, absolutely. It is built into our requirement. So I think that's the simplest way I can answer it. It is built into our requirement for the shielded zone for radio astronomy, indeed. And that's a question that keeps coming back, and that proves how important it is that we are compliant to those regulations. And then it is about communication. Obviously, we can be conscious and abiding by regulation that we are aware of, and that we are very, very lucky to be supported by both the European Space Agency and NASA in the development of Lunar Pathfinder, and then Moonlight is a NASA initiative. So we have a very privileged position to be aware of those. But in any case, if there were some that we would be missing, then we would be more than happy to be reached out to and challenged on what we're doing, obviously.
Okay. Very good. Time flies when you have fun, so we only have 4 minutes left. I'd like to go first of all to Alison, if you have any further comment you wanted to make on that topic, and then we're gonna go to some concluding remarks.
I just wanted to quickly jump back to the interoperability comment. And I think that is so incredibly important that we need to consider that. I think there's been a lot of development that is not focused on that, and states have wanted to keep their own information secret, and private companies normally want to just keep their information secret and not share a lot of details. But I think from a human rights perspective, if we're going to have people on the moon, we need to be able to make sure that we're able to take anyone in, help anybody who needs it in an emergency, and that's why interoperability is so important.
I definitely agree, and I think interoperability will be a great tool of international cooperation in general, right? It is going to be the way that we can facilitate certain dialogues in the name of efficiency and of providing a better service to everyone. So we have essentially reached the end of our panel. This was an extremely insightful discussion. Thank you all so very much. I don't know if there is any final remark that everybody wants to make before I go into some very final conclusions. Bob, Maxim, Nelly, Alison, any final thing you want to say on your side? Okay, I guess we have been discussing a lot.
My very short, not conclusion, but just to wish. I would like to wish success to all incoming lunar missions, because it's not only the Russian mission which I tried to shortly represent in my talk. I would like to wish success to other countries, because we will get more information by help of this mission, and potentially then we have several landing missions at the moon at the different location. It provides for us several information, including science, technology, and I think the information for the consideration how to organize our international cooperation.
Totally. Godspeed to everyone, as I guess it's common custom in the space community. Maxim, you made an excellent point. We need a diverse pool of people acting on the moon, and we wish all success to everybody, because nobody can do this alone. And hopefully, and that's also the responsibility of lawyers, but not just lawyers, we'll find a way to work together in a peaceful, prosperous, and sustainable way. And I think that's also a very nice theme for our conclusion. What I just would like to say is that the vision for the present of the Moon Village, I would say it's very encouraging. It's very cooperative. We've seen that we need to investigate a number of issues, but I think we are on the right track. We have the intent to do that. We have wonderful people working on it. We are developing the foundations for something that could really change the course of space exploration. And so I'm very much looking forward to tomorrow's panel, which will be in Lunar Future. So please stay tuned for that. It will be by my co-chair of the International Program Committee, Georgios, who will talk about future visions for the Moon Village. How are we going to be in 2040, 2050, right? So hopefully it'll build upon the discussion we had today, and I would invite all of you to look at that and follow that panel. To conclude, I'd like to thank Alison, Nelly, Maxim, Bob. Thank you so much. It has been a pleasure listening to you, hearing your presentations, reading your papers. And I definitely think that this is just the first of many discussions we'll hopefully have again together in another opportunity. So thank you so much. Thanks also for the audience, for the questions, for joining us. It was a great pleasure. And thanks to the MBA for organizing this insightful panel discussion and event. Thank you all.
Thank you.
Bye-bye.
Bye-bye.
Thanks.
Thank you.
Thank you, everyone. Thank you.
We now continue with the status report of the Global Expert Group on Sustainable Lunar Activities, GEGSLA, by the President of the Moon Village Association, Giuseppe Ribaldi.
So again, good morning, good afternoon, and good evening. My name is Giuseppe Ribaldi, and I am going to present the status of the Global Expert Group on Sustainable Lunar Activity in my capacity of Executive Secretary of this group. So let me explain what is this group and the origin of this activity. So as you know, the Moon Village Association has undertaken a number of activities And among these activity, to foster the cooperation, peaceful cooperation on the moon exploration and utilization, there is the issue of lunar governance. So in 2020, the Moon Village Association has issues the so-called best practice for sustainable lunar activity, which is indeed the preliminary definition of a common level playing fields for lunar activity. Subsequent to the best practice, it was felt that we needed to do more. And this is what I'm going to present with you. So the critical issue, which basically is at stake, is that in the next few years, actually starting from next year, in 2022, there will be several lunar missions from private as well as government organizations. And particularly for next year, there will be 5, if not 6, missions going to the moon. So at this point in time, do not exist a mechanism of coordination to basically inform each other about basically lunar activity around or on the moon. And this, of course, it's a challenge because it could lead to some problems, to some risk. So in order to preserve the peaceful use of space, and together with the desire to become a new area of sustainable space exploration on the moon, we have been, let's say, obliged to move on and try to define the famous common level playing field for all upcoming lunar missions. So a number of issues must be addressed to ensure sustainable lunar exploration and settlement in and around the moon. And this is including, for example, mitigation of the creation of debris in lunar orbit. I'm afraid that everyone is aware of the trouble that we have in Earth orbit because this issue was not taken seriously from the beginning, but only at the very late stage. A definition of standard related to enable interoperability of the different missions, as well as regulating access to natural resources. So as a result of that, basically of these critical issues, the MVA, as I said, has proposed the creation of this multi-stakeholder group, which is called Global Expert Group on Sustainable Lunar Activity, GEXLA, and you can see the logo. This group embodies representative of space agency, government, as well as industry, academia, civil society, and as for all the activity of the Moon Village Association, the public. So this organization is basically trying to define basically a recommended framework and key element that should support the creation of enabling environment for peaceful, safe, and sustainable activity on the moon and in orbit, which is, of course, in the interest of basically humankind and of all countries, irrespective of their degree of economic and scientific progress. So the document which is being elaborated will define general principles as well as some of their own key elements like lunar activity, commercial activity, and many others, as well as will include some very detailed guidelines for implementation of these key elements. So you can see the principle and the key elements as a bottom down, and guidelines as a top down and bottom up for the guidelines. What is the status of the work? We had a kickoff, so it's a very recently start of the operations of this activity. On 25th of February, we have monthly meeting, and which is, of course, makes it challenging, but this allows really to have many members and observers which are participating. The goal is to complete the work by the end of 2022. So right now, we have about 38 members belonging to 12 space agencies, 10 from industry, 10 from academia, and 6 from civil society. We have more than 180 observers, and the number is increasing, and more than 50 countries which are represented. At this stage of the activity, governments are still welcome to become full member. It is enough that they will inform us, and we will let them in, because we are, of course, very interested to have as many countries as possible. And then also observer and sponsor, on the contrary, they are constantly open. So basically, the next point is related to the organization of the activity. So in order to have a working, effective of the working group, there has been the need to divide in the operational, in the running of the activity, the group in 4 subgroups. One is dealing with information sharing, which is important, for instance, for notification of where the lunar mission are going, amongst other. The second is related to safe operation and lunar environmental protection, meaning how far you can land without impacting some other stakeholder, as well as issues related to how to try to preserve the lunar environment in order that it remains sustainable for future mission. Subgroup 3 related to compatibility and interoperability of the mission, because the moon is an hostile environment, and in order to be able to, let's say, work with each other and help each other, you need to be able to communicate with each other and having technical standards which are similar. This will, by definition, increase cooperation. And then finally, responsible governance, intended as a way for all humankind to go to the moon in a very, let's say, ethical way, which will really preserve it for the future generation. The way the work of a group is made by Zoom, by, let's say, telecommunication online, so you can see one part of the screen of people from all over the world. So we meet every month in a closed environment, meeting the observer and the members, but we also held annual or biannual webinars with the public in order to explain to the public what we do. And I think the activity are going very well, and so we are on target to report all the findings and the documents to the UN Committee on Outer Space, COPUOS. Moon Village Association has an observer status in the UN COPUOS, so this will allow MVA to propose an agenda item to discuss lunar governance in 2022, subject, of course, to the support of member states, since MVA is an observer, and so it cannot propose this kind of action. Only member states can do. The end goal is to present to the COPUOS the result of this activity by the end of 2022, which will include the document that is here presented. So I hope that with this information, you will be able now to follow the development of GEXLA, follow the MVA website where there is a specific GEXLA webpage, and I hope you will join us in this very important activity, like the definition of a common lunar governance. Thank you, and have a nice day.
Thank you to our speakers, panelists, and moderators. With this, we conclude day 1 of the 5th Global Moon Village Workshop and Symposium. Please don't forget to visit our repository of presentations from the call for papers. From Nicosia, Cyprus, we wish you a good day, good afternoon, or good night, depending where you are, and looking forward to seeing you tomorrow.